Beneath a vast, icy silence lies a land unlike any other on Earth. Antarctica, a frozen continent at the bottom of the world, untouched by time, cloaked in secrets. For centuries, it has defied explorers, baffled scientists, and whispered enigmas into the cold winds that sweep its desolate plains. Here, temperatures plummet beyond human tolerance, yet strange anomalies continue to emerge. Signals from deep beneath the ice, impossible geometric structures captured on satellite images, and fossilized remnants of life where none should exist. How can a continent so barren hold such tantalizing mysteries? Could there be lost civilizations entombed beneath miles of glacial ice? What forces sculpted perfectly symmetrical shapes in one of the harshest environments known to man? And why do some researchers report magnetic irregularities that distort navigation itself? These aren't fantasies. They are questions science still struggles to answer. This isn't just about Antarctica. It's about what we don't know, and what we might discover if we dare to look closer. So sit back, bundle up, and let's journey into the unexplained, deep into the heart of the last true frontier. At the heart of Earth's most remote continent, buried more than a mile beneath the ancient Antarctic ice, lies one of the most ambitious scientific instruments ever built, the IceCube Neutrino Observatory. To the untrained eye, it's invisible. From the surface, there are no massive antennas or sprawling arrays, only a few scattered buildings, dwarfed by the endless white expanse of the South Pole. But deep below, in the silence of the frozen abyss, a vast network of over 5,000 optical sensors waits, watching for flashes of light that last less than a billionth of a second. IceCube was designed to detect neutrinos, elusive subatomic particles that pass through everything, including us, at nearly the speed of light. These ghost-like messengers come from the most violent and distant events in the universe: supernovae, black holes, even the Big Bang itself. And yet, some of the most perplexing data doesn't come from space at all, but from the Earth, or rather, from within it. In 2016, researchers noticed something strange. Neutrinos are expected to travel in straight lines. When they pass through the Earth, from the northern hemisphere, through the planet's core, and up into IceCube's sensors, only the most energetic particles make the journey. The less energetic ones are absorbed or scattered. That's the theory. That's the model. But IceCube began to detect ultra-high-energy neutrinos that shouldn't be there, particles emerging from directions they shouldn't have been able to travel through. They were coming upward, as if something deep beneath the Earth was generating or altering them in ways our physics can't explain. The anomalies sparked a flurry of debate. Were they errors? Misread data? Statistical flukes? Or was something more profound happening under the ice? The first explanations were cautious, grounded in known science. Some speculated that these could be tau neutrinos, a rarer form that might behave differently under extreme conditions. Others suggested that perhaps the models of how neutrinos interact with matter at such high energies need refining. But as the data accumulated, the questions deepened. Could these signals point to the decay of hypothetical particles, predicted by theories that go beyond the standard model of physics? Particles like sterile neutrinos, or even candidates for dark matter? Some researchers began to entertain the possibility that we might be glimpsing new physics, phenomena that haven't been observed anywhere else in the universe. And then, there are the more unconventional ideas. A handful of voices, from outside the mainstream, began to draw connections between the anomalies and a very different kind of theory, one involving ancient structures buried beneath the Antarctic ice, technologies lost to time, or even signals not from this Earth. The notion of advanced civilizations in Antarctica isn't new. It stretches back to fringe interpretations of old maps, such as the Piri-Reis map of 1513, which some claim shows an ice-free coastline of Antarctica long before it was officially discovered. In these interpretations, Antarctica becomes more than a frozen desert. It becomes a vault of forgotten history, or something not meant to be found. Could it be that the IceCube sensors are picking up more than just cosmic particles? Could some unknown geological or artificial process be taking place under the ice, releasing bursts of energy we don't yet understand? There's no physical evidence to support these ideas, only speculation, curiosity, and the lingering sense that Antarctica holds more secrets than we realize. Yet IceCube itself is real. The anomalies are real. The particles that arrived from directions they shouldn't have traveled. Those are documented in peer-reviewed journals. The debate is ongoing, and science is still searching for a definitive answer. Meanwhile, the observatory continues to listen. Its sensors, frozen in time and darkness, watch for more flashes. Tiny traces of a vast, invisible world. Perhaps these anomalies are a hint of a deeper truth about the universe. Or maybe they're the result of something closer, something beneath our feet that we've yet to comprehend. Why would neutrinos behave differently beneath Antarctica? What could generate such energy from within the Earth's crust? Or deeper still, the mantle, or even the core? Are we seeing the limits of human understanding, or the first signs of a new chapter in physics? One thing is certain. In a place as isolated and extreme as Antarctica, even the smallest anomaly echoes like a roar. And as long as IceCube keeps watching, the questions will remain, suspended in the ice, untouched by time, waiting for someone to answer them. What else lies hidden beneath a continent of silence? As IceCube continues its silent vigil beneath the surface, collecting signals from the deepest corners of the universe, above, the landscape of Antarctica is shifting. Not slowly, but suddenly. High above the buried sensors, great rifts are tearing open the ice. Vast, jagged cracks, some stretching for dozens of miles, appear where there was once only smooth, ancient glacial terrain. To witness one is to feel dwarfed by nature's raw and unrelenting power. These are not minor fractures. They are chasms, deep, dark slashes across the white surface, like scars from some unseen hand. The most dramatic of these events don't unfold over centuries. Some happen in hours. A crack can appear seemingly overnight, racing across the ice sheet at speeds up to 10 feet per second. Fast enough to outpace the human eye. One moment, the landscape is still. The next, it's broken wide open. Satellite images have captured these ruptures with startling clarity. And each time, the question resurfaces. Why now? Why here? Geologists and climate scientists offer explanations rooted in physics and glaciology. The Antarctic ice sheet, after all, is constantly in motion, flowing outward from the center of the continent under its own weight. Tectonic stresses, temperature fluctuations, and ocean tides all contribute to this dynamic system. Ice shelves, the floating extensions of land ice, are particularly vulnerable. When warmer ocean currents melt them from below, their structural integrity weakens. Crevasses form, and eventually, the ice gives way. But some recent rifts have defied expectations. In 2017, a massive crack in the Larsen Sea ice shelf led to the calving of an iceberg the size of Delaware, one of the largest ever recorded. While scientists had tracked its development, the final break still occurred faster than predicted. Since then, other shelves, including Brunt, Pine Island, and Thwaites, have developed similar unpredictable ruptures. Some are followed by calving events. Others simply stop growing, as if held in place by something unseen. Researchers have noted that some of these rifts emerge not from the fragile edges of the ice sheet, but from deep within its heart, areas thought to be more stable, colder, and older. In places where environmental models suggest cracks shouldn't form, they do. And in some cases, they seem to form in symmetrical, almost patterned ways. Could it be that our models are incomplete? That we're missing something fundamental about the way Antarctic ice responds to the forces around or within it? Some suggest there could be subterranean causes, hidden mountains or geothermal hotspots beneath the ice, exerting unexpected pressure. Indeed, radar imaging has revealed complex, rugged terrain under Antarctica's surface, including entire mountain ranges like the Gamburtsev Mountains, buried beneath miles of ice. Other theories point toward meltwater lakes, trapped between bedrock and ice, that periodically fill and drain, shifting the ice above them in sudden, dramatic fashion. These subglacial lakes are not hypothetical. Over 400 have been identified so far, many connected by a labyrinth of channels that may stretch across the continent. When these lakes suddenly empty, the overlying ice can collapse, triggering fractures that ripple outward. Still, questions remain. What triggers these lake drainages? Why do some rifts form in areas with no known lakes or heat sources? Could there be geological forces at work? Tectonic activity beneath the continent's crust that we have yet to fully map? And then there are those who ask, what if the rifts aren't purely natural? Outside mainstream science, a handful of voices have speculated that the sudden formation of some cracks may not be random at all. Theories range from underground facilities reacting to internal pressure, to lost ancient infrastructure crumbling beneath the weight of time. These ideas, often dismissed as fantasy, persist on the edges of the conversation, fueled by satellite images showing unusually straight lines, angular formations, and abrupt terrain changes beneath certain regions of the ice sheet. In 2018, one such image circulated online, depicting a perfectly rectangular feature partially exposed in a newly fractured ridge. Experts attributed it to a natural break in a crevassed area, an artifact of how ice splits along weak points, yet the stark geometry struck a chord. How often does nature draw such clean lines? It's easy to let the mind wander in a place as untouched as Antarctica, a continent so remote and hostile that 99% of its landmass remains hidden beneath ice. What else lies entombed beneath that ancient surface? Could we be witnessing signs of long-forgotten changes deep below, relics of Earth's past geology, or something even older? Geologists continue their work. Teams deploy radar, GPS, and seismic sensors to monitor the slow shifting of the continent. Climate models grow more sophisticated each year, but no algorithm has yet predicted exactly when or where the next great crack will appear. The rifts remain, silent, sudden, and largely unexplained. And as we look down from satellites, or fly over them in research aircraft, the scale is humbling. The ice fractures not just through space, but through time, splitting apart layers that have remained untouched for over 1 million years. Every break is a window, a glimpse into something ancient and unknowable. We can measure their depth, we can trace their outlines, but we cannot say with certainty what lies at their end. Is it only ice that breaks beneath us, or the edges of our understanding? As cracks open across the ice and hidden forces reshape the continent below, there is one place in Antarctica where the Earth's inner fire rises defiantly to the surface, glowing, alive, and strangely unyielding. Mount Erebus. Rising over 12,000 feet above the Ross Ice Shelf, this stratovolcano stands as one of the southernmost active volcanoes on Earth. Its name, taken from Greek mythology, means darkness, a fitting title for a mountain that holds one of the planet's most unusual geological phenomena, a persistent lava lake. In this frozen land of silence and stillness, Erebus is an anomaly, a fiery heart beating in a realm of ice. Unlike most volcanoes, which erupt briefly before returning to dormancy, Erebus burns with near constant activity. At its summit, deep within a rugged crater, a pool of molten rock bubbles continuously, exposed to the open air. It is one of only a handful of persistent lava lakes known to science, and by far the most remote. Discovered in 1841 by the British explorer James Clark Ross, Mount Erebus has fascinated and puzzled researchers ever since. The existence of a lava lake was confirmed nearly a century later, in 1972, when scientific teams finally reached the crater rim. What they found challenged long-standing assumptions about volcanic behavior and raised new questions about what might be stirring beneath Antarctica's surface. How can such intense heat persist in the coldest place on Earth? Standard geological explanations offer part of the answer. Erebus sits above a mantle plume, a column of hot rock rising slowly from deep within the Earth. These upwellings of magma are known to create volcanic hotspots, such as those responsible for the Hawaiian Islands. In Erebus's case, this plume penetrates the thick Antarctic crust, fueling constant eruptions and maintaining the molten lake. But the lake's consistency, its apparent refusal to cool or solidify, remains unusual. Lava lakes are inherently unstable. They typically collapse, crust over, or drain as the underlying magma chambers shift. Yet the Erebus Lake has endured, in some form or another, for decades. It fluctuates, yes, but never disappears entirely. Scientists have studied its chemistry, noting that the lava is composed of a rare type of phonolite, a thick, sticky magma rich in alkali elements. The gases released from the lake are equally intriguing, including high levels of carbon dioxide and sulfur, along with unusual trace compounds not often observed in other volcanoes. Is there something unique about Erebus's magma source? Or could the extreme isolation of Antarctica, free from tectonic interference, provide the stability required for such an enduring feature? These are the questions that occupy geophysicists. But outside the bounds of traditional science, Erebus has inspired other theories, stranger, more speculative. The continuous thermal activity beneath the mountain has led some to wonder whether Erebus could be connected to larger geothermal networks under the continent, networks that might help explain the presence of subglacial lakes, sudden ice rifts, and other anomalies. Could this volcano be just one outlet in a vast hidden system stretching beneath the Antarctic crust? Others have looked to the mountain's history of acoustic emissions, the low, rhythmic sounds it produces, known as infrasound. These deep, rumbling tones are inaudible to the human ear but detectable by sensitive instruments. They're generated by eruptions, but the patterns are not always predictable. Some have likened them to a kind of natural pulse, or signal. To fringe theorists, this opens the door to even more unorthodox ideas. There are those who suggest the Erebus lava lake may be more than geological, that it could be a marker, or even a byproduct, of long-lost technology buried beneath the ice. Stories of ancient civilizations, often tied to the enduring Atlantis myth, have long been projected onto Antarctica's vast, unexplored terrain. In this view, Erebus becomes not just a volcano, but a vent, a pressure release from something far older and far more hidden than we yet understand. And then there are reports, scattered and largely anecdotal, from early explorers who claim to witness strange lights or aerial phenomena near the mountain. Were these tricks of the atmosphere, the reflection of volcanic gases in the ice-laden sky, or something more difficult to define? To be clear, no physical evidence has ever emerged to support these fringe ideas. But the questions linger, not because of what we've proven, but because of what we haven't. Despite multiple expeditions, Erebus remains relatively understudied compared to other active volcanoes. Its location is punishing, its environment hazardous. The logistics of reaching the summit and maintaining instruments year-round are daunting. Much of its activity is still monitored remotely through seismic readings and satellite imaging. In the meantime, the lava lake continues, glowing softly beneath the Southern Cross, surrounded by snow and silence. It is a reminder that Antarctica is not merely cold and inert, but alive, unpredictable, and in many ways, still unknown. What keeps Mount Erebus burning when all around it is frozen still? How deep does its magma source reach? And what else might lie along that path? Perhaps it is just a volcano, albeit a rare and fascinating one. Or perhaps it is something more, a clue, a key, or a question carved into the southernmost land on Earth. Beneath the smoke and ash, what secrets are waiting to rise? As the fire of Mount Erebus glows defiantly beneath the southern sky, another, quieter phenomenon is unfolding across the ice. Not one of heat or stone, but of invisible forces that shape our entire planet. Magnetism. In the vast stillness of Antarctica, where snow drifts across frozen plains and the sky glows with the shimmer of distant stars, a mystery is unfolding beneath our feet. And it begins with the movement of Earth's magnetic field. The magnetic poles, north and south, are not fixed. They drift slowly, meandering through time. For centuries, this movement was gradual, almost predictable. But something has changed. Since the late 20th century, the magnetic South Pole has been accelerating. Once plodding along at a steady pace, it now moves with increasing urgency, shifting across the Antarctic continent faster than at any point in recorded history. The North Pole, too, has picked up speed, drifting away from Canada and toward Siberia at nearly 40 miles per year. But it's the behavior near Antarctica that has drawn growing attention from scientists, navigators, and those who track subtle changes in the Earth's systems. Why is the pole moving faster now? And why here, at the edge of the world, is the change so pronounced? The location itself is already one of the most mysterious and inaccessible regions on the planet. The magnetic South Pole doesn't align with the geographic South Pole. Instead, it sits far off center, currently located just off the coast of Adelie Land in East Antarctica, drifting westward with quiet insistence. Standard science tells us that Earth's magnetic field is generated by the motion of molten iron within its outer core, a planetary dynamo spinning beneath our feet. Variations in the flow of this liquid metal can shift the magnetic field over time, causing the poles to wander. Magnetic anomalies, areas where the field is unusually weak or strong, can appear as a result of these internal currents. One such anomaly exists beneath West Antarctica. The Wilkes Land anomaly, discovered via satellite-based gravity mapping in the early 2000s, appears as a massive, dense region beneath the ice, over 300 miles wide, buried under miles of frozen crust. Some scientists believe it may be the remnant of an ancient asteroid impact. Others suggest it could be an upwelling of mantle material, or something else entirely. Whatever its origin, it coincides with disturbances in the magnetic field, subtle irregularities that resist simple explanation. Could this anomaly be contributing to the pole's accelerating drift? Could hidden features beneath the ice, long obscured by millennia of snow and silence, be subtly influencing the Earth's deepest processes? Mainstream geophysics focuses on the core and mantle. Yet, as models grow more complex, the sheer pace of change continues to surprise researchers. In 2019, the magnetic field shifted so quickly that it forced an unscheduled update to the World Magnetic Model, a crucial tool for navigation systems used by aircraft, ships, and even smartphones. This is not merely academic. The stability of our global infrastructure depends, in part, on the predictability of the planet's magnetic field. And still, Antarctica holds its secrets close. Some researchers have noted that the South Atlantic Anomaly, another area of magnetic weakness, appears to be expanding toward the southern polar region. This weakening of the field could expose satellites and high-altitude aircraft to increased radiation, affecting communications and navigation. It has also raised the question, could we be witnessing the early stages of a magnetic pole reversal? Earth's magnetic field has flipped before, hundreds of times over geological history. The last full reversal, known as the Brunhes-Matuyama reversal, occurred approximately 780,000 years ago. These reversals are believed to unfold over thousands of years, but the process remains poorly understood. Could the current acceleration be a prelude to another flip? Or is it a temporary fluctuation, a ripple in the deep, metallic tides below? Beyond science, the accelerating pole movement has stirred speculation among those who look beyond conventional models. Some propose that electromagnetic disturbances could be related to external cosmic forces, solar cycles, planetary alignments, or even galactic energy fields. Others tie the magnetic drift to ancient prophecies or lost knowledge, suggesting that the ancients may have known more about Earth's shifting magnetism than we realize. Among the more fringe theories are claims of artificial interference, technologies hidden deep within the ice, subtly altering the Earth's magnetic environment. Satellite images showing straight lines, unnatural geometric shapes, or patterns of heat emissions near magnetic anomalies have fueled such ideas, though mainstream science attributes these to natural geological formations or digital imaging artifacts. Still, the coincidences are compelling. Why does the Wilkes Land anomaly align so closely with magnetic irregularities? Why has the pole's drift intensified only in recent decades? Is this a cyclical process, or the sign of something more unprecedented? We may never fully understand the forces beneath us. The magnetic field is a veil, invisible, shifting, yet vital to life on Earth. It shields us from solar radiation. It guides migratory species. It anchors our technology. And it is changing, faster than anyone expected. From the frozen expanse of Antarctica, the pole moves steadily onward, like a compass needle pulled by an unseen hand. Scientists trace its path. Instruments record its velocity, but no one can say for certain what lies ahead. What happens if the poles continue to accelerate? Will the field weaken further, or flip entirely? Will we adapt? Or will we discover something entirely new about the forces that shape our world? In the end, we are travelers on a planet whose magnetic heart is always in motion, and perhaps always keeping secrets. As Earth's magnetic field continues its silent drift, pulling against the unseen architecture of the planet, some researchers have begun to wonder, could the anomalies we observe in Antarctica be linked to other mysteries, far from the frozen South? To explore this question, we must travel to a remote corner of southeastern Siberia, to a dense, brooding forest near the Potom River. Here, concealed by miles of taiga wilderness, rises a strange and ancient formation, one that has resisted explanation since the moment it was discovered. The Patomskiy crater. Also known as the Fire Eagle Nest by local Yakutian tribes, this massive structure resembles a stone funnel, 40 meters tall and more than 180 meters wide at its base. From above, it looks like a colossal impact site, but there is no sign of an actual impact. No scorched earth, no surrounding debris field, no meteorite fragments ever recovered. It's not made of volcanic rock either. In fact, no known volcanic activity exists in the area. Discovered in 1949 by Russian geologist Vadim Kolpakov, the crater immediately baffled researchers. Kolpakov noted its peculiar shape, a central mound surrounded by a wide ring, as if something had burst up from beneath the earth rather than crashing down from the sky. He was so struck by the odd formation that he postponed reporting it, fearing ridicule from the academic community. What created this strange cone of shattered limestone and fragmented rock, rising from an otherwise featureless landscape? Mainstream theories have been offered. Some suggest a massive gas explosion from deep within the Earth, or a rare type of cryovolcanism, volcanic-like activity involving water, ice, or methane rather than molten rock. Others point to a possible landslide, or even the slow collapse of an underground cavern. But none of these explanations fully account for the structure's symmetry or its unusual magnetism. Yes, magnetism. Measurements taken over the decades have revealed anomalies in the magnetic field around the Patomskiy crater. Compasses behave erratically. Instruments register small but consistent fluctuations. In some areas, the strength of the field increases, suggesting a high concentration of ferromagnetic minerals. Yet soil samples fail to reveal such materials in any significant amount. And then there's the mystery of time. Dendrochronology, the study of tree rings, shows that vegetation around the crater abruptly stopped growing around 250 years ago. Something happened here. But what? In recent years, a handful of researchers have begun asking a bolder question. Could the Patomskiy crater be connected, in some deep or forgotten way, to the anomalies beneath Antarctica? At first glance, the idea seems far-fetched. One is a frozen continent, the other a remote stretch of forest in Russia. But a few curious alignments, literal and theoretical, have prompted fresh curiosity. First, the geographic alignment. When tracing certain magnetic lines of force across the globe, some researchers noticed that a few of them, particularly those associated with areas of magnetic weakness or flux, seem to connect points like the Patomskiy crater and regions in East Antarctica, such as Wilkes Land. These are not direct connections, but energetic correlations, observed in geomagnetic modeling. Could there be a deeper structure, a kind of subterranean architecture, connecting regions of anomalous magnetism? This idea is not new. In the late 20th century, geophysicists studying mantle plumes and tectonic flow proposed the possibility of global-scale networks of weakness or resonance within the crust. These networks, some suggested, could act like pressure valves or stress points, influencing seismic activity, magnetic field behavior, and even crustal deformation. If such a network exists, could both Patomskiy and Antarctica be nodes in this hidden system? Some fringe theorists have taken the idea further. They propose that both regions were sites of ancient impact, not necessarily from asteroids, but from something else. Unknown craft, extraterrestrial objects, technological relics from a forgotten epoch. The crater's conical shape, the disturbed magnetism, the disrupted vegetation, all, they argue, suggest not a natural event, but a controlled one. A signature left behind. And what of the timing? Russian researchers have suggested that the Patomskiy formation may be far younger than originally assumed, perhaps only a few hundred years old. If so, then it would post-date the Tunguska event of 1908, and its origin becomes even more curious. Could it be the aftermath of a subterranean explosion, a buried object venting pressure, or a geological response to something we've yet to define? No evidence exists to confirm these theories, and yet the crater remains. Still, unmoving, magnetic, and the forest around it remains largely untouched, isolated, like a forgotten monument to an event we cannot explain. Back in Antarctica, similar features, subsurface anomalies, magnetic irregularities, unexplained heat signatures continue to emerge beneath miles of ice. We dig, we measure, we model. But for every answer, a dozen new questions appear. Could it be that these mysteries are not isolated? That what lies beneath Siberia and what churns below Antarctica are two facets of the same unknown? Or are we simply finding patterns where none exist, drawing lines across the globe in our human search for connection? Perhaps the truth lies not in what we see, but in what we still cannot. Is the Patomskiy crater a geological curiosity, or a key? A silent mark left behind by forces we have yet to name? And if so, what else has been marked beneath the crushing silence of Antarctica, where the ice lies thick as mountains and time itself seems frozen? Something stirs. Miles below the surface, far from the light of day, heat pulses through the depths. It moves silently, invisibly, melting ice from within, shaping the foundations of a continent few have ever seen. This is not the wind or the cold, or the vast stillness of glaciers creeping over time. This is fire. Hidden volcanic activity beneath the Antarctic ice sheet is one of the continent's most unsettling mysteries. It is not the dramatic, explosive kind we imagine when we think of volcanoes, not lava fountains or glowing craters, but a slow, persistent burn. A warmth that should not be there, yet undeniably is. In 2017, a group of scientists made a startling discovery. Using radar data and seismic imaging, they uncovered the presence of more than 90 volcanoes beneath the West Antarctic ice sheet, many of them previously unknown. Some are dormant, others potentially active. One of them, Mount Sidley, rises nearly 4,200 meters from the bedrock, taller than Japan's Mount Fuji, yet its peak remains buried beneath ice. How is it possible that such immense volcanic features could lie hidden, undetected, in an age of satellites and digital mapping? The answer lies in Antarctica's nature. Its thick ice obscures the landscape beneath, burying even the tallest peaks under thousands of feet of compressed snow. Traditional methods of geological observation, like visual surveys and thermal imaging, often fail in this extreme environment. The continent's vastness, remoteness, and volatility make it one of the least understood places on Earth. But even through the ice, the heat leaves traces. In certain regions of West Antarctica, particularly near the Pine Island and Thwaites glaciers, scientists have detected unusually high levels of geothermal heat. Subglacial lakes, some the size of entire cities, remain liquid year-round, insulated not just by the weight of ice above, but by warmth rising from below. In some areas, radar instruments detect sudden melting events or changes in ice flow, suggesting the presence of hydrothermal activity. Is this merely tectonics at work, a natural consequence of Antarctica's place in the planet's puzzle of continental drift? It's worth noting that Antarctica wasn't always frozen. Roughly 100 million years ago, during the Cretaceous period, it was part of the supercontinent Gondwana, a lush, temperate land teeming with forests, rivers, and life. Volcanic activity during that era shaped much of the bedrock we now struggle to study. Even today, Antarctica lies along a tectonically active rift system known as the West Antarctic Rift. This region bears a striking resemblance to East Africa's Rift Valley, a place known for ongoing volcanic activity and crustal deformation. So, the science is solid. Volcanoes exist beneath the ice. They have erupted before. Some may erupt again. But here is where the mystery deepens. What if the volcanic heat is not only shaping the ice, but accelerating its disappearance? Some researchers argue that subglacial volcanism could be contributing more significantly to ice sheet instability than previously thought. The heat weakens the base of the glaciers, lubricates their flow, and speeds their movement toward the sea. Combined with rising global temperatures, this dual assault could destabilize entire ice shelves in a matter of decades, or sooner. But not everyone agrees. Critics point to the lack of definitive eruption data, the limited number of instruments, and the challenges of modeling such a complex system. The debate continues, unresolved, and yet unusual events persist. In 2004, researchers at Mount Erebus, a known active volcano near the Ross Ice Shelf, recorded strange harmonic tremors and unexplained energy pulses. In 2010, satellite instruments detected a sudden temperature spike beneath the ice near Marie Byrd Land, followed by subtle deformation of the surrounding terrain. In 2018, NASA's Operation Icebridge revealed a massive cavity beneath the Thwaites Glacier, large enough to fit Manhattan inside, suggesting rapid, unexplained melting in a region far from the surface. Could this be the result of hidden volcanic activity? Or is something else at work beneath Antarctica? Fringe theories, as always, attempt to fill the gaps. Some suggest the volcanic heat might not be natural at all, that it could be evidence of artificial systems hidden deep underground. Theorists point to the symmetrical shapes detected in some satellite imagery, the perfectly straight crevasses, and strange heat signatures as possible signs of buried structures or energy sources. Others invoke the idea of ancient civilizations, long lost beneath the ice, whose technologies might still linger, generating heat through unknown means. More speculative voices go further still. They ask, could Antarctica's volcanic systems be interconnected with other global anomalies? Are there ancient energy grids, deep planetary circuits, or magnetic pressure points that link one side of the world to the other? If so, is the activity we observe today merely the aftershock of something much older? These ideas, while not accepted by mainstream science, continue to circulate. Not because they are proven, but because the silence of Antarctica leaves room for wonder. And perhaps that's what lies at the heart of this mystery. We know that volcanoes are there. We know that heat flows upward, unseen. But how much do we really understand about what lies beneath the thickest ice on Earth? Why are so many of these volcanoes concentrated in one region, directly beneath some of the most rapidly melting glaciers? Why do their signatures change without warning, as if responding to some deeper rhythm? And how many more remain undiscovered, quietly altering the future of our planet from beneath a frozen shroud? In the end, Antarctica is not merely a landscape of ice, but a crucible of fire. And the deeper we look, the more it seems that something ancient still breathes beneath the cold. From deep beneath Antarctica's ancient crust, volcanic fire simmers in silence. We've seen the impact of this hidden heat, melting ice, shaping landscapes, awakening dormant fears of instability. But in one place, the fire reveals something more: entranceways. At the heart of Ross Island, rising more than 12,000 feet into the cold air, stands Mount Erebus, Antarctica's most famous volcano, and one of the very few on Earth with a persistent lava lake at its summit. A place of contradiction: ice and flame, silence and seismic activity, stability and unrest. For decades, scientists have studied its behavior, cataloging tremors, thermal vents, and its remarkably active inner chambers. But in the shadows of this fiery peak, another mystery has slowly emerged. Unmapped caves, subsurface passageways, hollow spaces warm enough to support life. And no one knows just how far they go, or what might be waiting at the other end. The story begins with heat. Thermal imaging and satellite surveys conducted by Australian researchers between 2011 and 2017 revealed unexpected anomalies near Erebus. These weren't just pockets of warm rock or elevated temperatures. They were long, tunnel-like voids beneath the ice, some stretching hundreds of meters. Carved by volcanic steam and geothermal forces, these ice caves are part of a vast system of subglacial voids that have only recently begun to be mapped. In 2017, scientists from the Australian National University made a startling announcement. Genetic traces, DNA fragments, from plants, algae, and even small invertebrates were found within the cave walls. Though no living organisms were directly observed, the data hinted at life forms surviving, perhaps even thriving, in this isolated, sunless environment. But how? In a place where temperatures outside plunge far below freezing, how could organic material remain viable? Could these caves be connected to something larger, an ecosystem untouched by the surface world? Researchers are cautious. They suggest these organisms may have been carried in by wind or deposited by seabirds. Yet the presence of genetic material deep within the caves, far from any surface exposure, raises deeper questions. Who or what was here before? Exploration of these passageways is notoriously difficult. The terrain is unstable. Sections of the ice can collapse without warning. The caves themselves emit gases, some noxious, others simply hot, that distort readings and interfere with equipment. In many areas, GPS fails entirely. Human access is limited, and so much of what we know comes from remote scans, thermal models, and fragmented data. But what we do know is this: the caves are real, and their scale is staggering. Some experts have compared the system beneath Mount Erebus to lava tubes found in places like Iceland or Hawaii, vast hollowed tunnels formed by flowing molten rock. In places like Hawaii's Kazumura Cave, lava tubes can stretch for more than 40 miles beneath the surface. Could Erebus's system be just as extensive? If so, why has so little of it been explored? That question fuels a growing sense of intrigue, and for some, suspicion. Satellite images, some leaked and others publicly available, have occasionally shown what appear to be unusually symmetrical depressions near the base of Mount Erebus. Some show straight-edged ridges and openings that seem inconsistent with natural erosion. These are often dismissed as artifacts, glitches in imaging, or misread data, but they continue to draw attention from those who believe something else may lie beneath. Fringe theories have emerged, as they often do in places science cannot fully penetrate. Some theorists suggest that the cave system might extend far deeper than currently believed, perhaps connecting to vast subterranean chambers beneath the ice sheet itself. Could these passageways be remnants of ancient geothermal civilizations, refuge zones used in pre-glacial times, or evidence of advanced intelligence long buried beneath the Antarctic crust? In 2018, a viral story circulated claiming that a group of satellite contractors discovered large artificial structures hidden in the caves, columns, door-like formations, geometric patterns. The claims were never substantiated and were quickly dismissed by scientific agencies. Still, the story refused to vanish. Why? Because Antarctica lends itself to silence. And in silence, speculation takes root. Others point to the Nazi expeditions to Antarctica in the late 1930s, when German vessels mapped portions of Queen Maud Land and established temporary encampments. Some believe that hidden cave systems like those near Erebus could have offered shelter, or something more. Though no hard evidence supports these claims, declassified intelligence documents show that post-war Allied forces did investigate these regions, tracking weather patterns, ice flows, and, according to some reports, unknown aircraft. Most scientists reject such ideas, but even they admit the Erebus caves are among the least studied geothermal systems on Earth. Why are so few expeditions dedicated to exploring them? Is it due to logistics, or something else? We know from previous missions that Antarctica is not a static continent. Its surface conceals rivers, lakes, heat plumes, and now cavernous networks of volcanic origin. If Erebus hides such passageways, is it the only place? Or are there other volcanoes buried beneath the ice with their own cave systems, still waiting to be discovered? And if microbial life, or its remnants, has been found in the warmth of these caves, could other, more complex organisms survive here too? What might evolve in total isolation, shielded from the surface world for centuries, or longer? The caves near Mount Erebus challenge our assumptions not just about geology, but about life itself. How many more entrances lie undiscovered beneath the snow? How deep do these tunnels go? And if we were to follow them, where might they lead? QAs, we leave the heated hollows beneath Mount Erebus behind. The vast Antarctic plateau stretches out once more, flat, blindingly white, and seemingly unbroken. But here, in this immense silence, something strange has been appearing. Crater-like holes, massive circular depressions torn into the ice. Some are shallow, others cut hundreds of feet deep into the frozen crust, perfectly round, with sharply defined rims, as if etched by a deliberate hand. These aren't ancient formations. They appear suddenly, sometimes overnight, and just as quickly, they vanish beneath drifting snow, concealed once again in the continent's shroud of secrecy. What causes these vast, ice-bound sinkholes to open without warning? Most are found in remote regions, along ice shelves, in the flat expanses of West Antarctica, and occasionally near the coastlines where warmer currents gnaw at the base of glaciers. At first glance, they might seem to be the result of melting, water pooling beneath the surface, weakening the structure until collapse occurs. And in some cases, that's exactly what's happening. But not all. In 2020, a team of glaciologists mapping the Denman Glacier region encountered a series of depressions unlike anything they'd expected. One, nearly 500 feet deep and almost perfectly circular, was located far from any known melt zone. No subglacial lake, no geothermal hotspot, no fault line, just a hole. Some scientists proposed that these structures were formed by sudden internal collapse, large voids created by decades of internal thinning finally giving way. Others suggest subglacial water pockets under intense pressure may burst upward, disrupting the surface in violent, unseen events. The problem is, these explanations don't account for the regularity of the shapes or the isolated locations in which they appear. Unlike more familiar sinkholes that form in limestone or sediment, these are forming in ancient ice, compressed, dense, and seemingly stable. In many cases, instruments placed nearby detect no warning tremors, no subsurface shifts, no heat anomalies, just a sudden emptiness. Could these craters be collapse points over hidden caverns, similar to those beneath Erebus? Or something else? Some researchers point to radar imaging conducted during Operation Icebridge, a NASA-led mission that used airborne sensors to map the contours of Antarctica's ice from above. In certain flyovers, large circular voids were observed, often at great depths. While most were dismissed as natural subsurface melt zones, a handful were flagged for further study due to their unexpected symmetry and unexplained origin. It raises a troubling question. Are we witnessing the surface collapse of something far larger, an unseen world of chambers and hollows, slowly giving way beneath the weight of the ice? Others speculate the formations might be tied to ancient meteorite impacts. Antarctica receives more meteorite strikes than most continents, not because more landmass is hit, but because the ice preserves these impacts better than soil or vegetation would. Over time, the ice flows over and around them, concealing all traces, until shifts in temperature or pressure cause the overlying sheet to fail. Could some of these sinkholes be ancient impact sites finally surfacing after thousands of years? But even this theory struggles to explain the suddenness with which some of these holes appear, emerging in locations that had been stable for decades, without any external force or clear cause. Then there are the fringe theories, ones that fall far outside the boundaries of accepted science, but persist nonetheless. One popular idea, circulating in online communities and speculative documentaries, suggests that some of these craters might be the remnants or entrances to massive artificial structures. Satellite images, often blurry and inconclusive, are cited as showing straight lines, concentric rings, or unnatural symmetry within these holes. Proponents claim they could be the collapse points of ancient facilities or long-buried vehicles, concealed for millennia beneath the ice. Others stretch further still, theorizing that the sinkholes mark the location of geothermal anomalies powered not by magma, but by unknown technologies, or by natural energy systems beyond current understanding. Some cite strange magnetic readings in the surrounding regions. Others point to old expedition reports, faint mentions of sudden terrain disruptions, unexplained losses of equipment, or the appearance of deep shadows where none should be. Of course, these stories lack direct evidence, but in Antarctica, a continent larger than the United States and Mexico combined, 99% of which is covered in over a mile of ice, the line between myth and possibility is difficult to draw with confidence. And yet, the holes remain. Silent. Gaping. Temporary windows into a world that refuses to reveal itself. In 2016, an Argentinian research outpost reported a depression forming within visual range of their station. Over the course of 48 hours, a clean-edged sinkhole widened to nearly 200 meters, revealing ice walls descending into darkness. Before the team could investigate further, a storm buried the structure completely. It has never been relocated. That story is one of many, brief glimpses, quickly lost. Are these simply natural collapses caused by the complex and chaotic behavior of melting ice? Or are we seeing the slow emergence of something long buried, once again breaching the surface? If so, what could be hidden beneath the oldest ice on Earth? Deep in the coldest, most remote places on the planet? Perhaps just geological quirks. Or perhaps echoes of something more. Something that predates our maps, our history, and maybe even our understanding. The holes do not speak. They open in silence, and they disappear in snow. But they leave behind questions, ones that no scientific consensus has yet been able to answer. What lies beneath them? And when the next one forms, will we be ready to look inside? The ice is never still. Though it may appear motionless, frozen in place by temperatures that can plunge below -80 degrees Fahrenheit, Antarctica is alive with movement. Massive glaciers inch forward with glacial patience. Subterranean rivers of meltwater pulse silently beneath the surface, and sometimes the continent shudders. But not all tremors can be explained. For years, scientists monitoring Antarctica's seismic profile have been registering unusual activity, low-frequency rumbles, deep vibrations, and subtle pulses that seem to emanate from beneath the vast ice sheet, not the sharp jolts of tectonic earthquakes. These are different, slower, rhythmic, at times almost intentional, and they don't match any known patterns. Some of the most persistent anomalies have been recorded beneath East Antarctica, particularly in the region known as the Gamburtsev mountain range, a mysterious subglacial mountain chain the size of the European Alps, entirely hidden beneath more than a mile of ice. Discovered during the International Geophysical Year in 1958, the Gamburtsev Mountains shouldn't exist. There's no plate boundary, no volcanic hotspot, no clear geological reason for a mountain range of this scale in the middle of a tectonic plate. And yet, there it is. Its peaks and valleys mapped only by radar, sonar, and seismic reflection. It's here, beneath this buried landscape, that the rumbles seem to concentrate. Seismographs positioned at remote research stations, some hundreds of miles apart, have recorded strange low-frequency waves traveling through the ice. Not powerful enough to be felt at the surface, but persistent, measurable, and oddly regular. In 2010, a cluster of such events was detected by a network of seismic instruments operated by an international science collaboration. At first, they were dismissed as glacial quakes, small, localized events caused by sudden movements of ice against rock. But glacial quakes are usually chaotic in their frequency and direction. These were not. They followed a pulse-like rhythm. Each wave arrived precisely spaced, as if operating on a schedule. What could cause such consistency? Some geophysicists theorized that subglacial lakes might be responsible. As pressure builds beneath the ice, sudden releases of water could create tremors as the crust shifts in response. Yet none of the nearby lakes, like Lake Vostok or Lake Concordia, have shown drainage patterns or volume changes that match the seismic data. Others proposed thermal activity, plumes of geothermal heat stirring the ground. But the heat signatures in these regions are faint at best, and so the mystery grew. Further south, in Marie Byrd Land, a massive, ice-covered expanse, roughly the size of Texas, similar rumbles have been detected, this time accompanied by transient electromagnetic anomalies. These microseisms, as they've been termed, are even more enigmatic. They appear irregularly, and sometimes in bursts, like short whispers from deep beneath the crust. Some recordings have captured tonal shifts, faint oscillations, as if something was resonating beneath the ice. These aren't sounds in the traditional sense, rather, they are vibrations passing through the earth, translatable into audible frequencies when slowed down and amplified. To some, they sound like groaning metal or breathing. Scientists remain cautious. Many suggest these anomalies are just part of Antarctica's underexplored geology, perhaps cryoseisms caused by sudden fractures within ice under stress, or long-range echoes of earthquakes from distant parts of the world. But not all the signals match these templates, and so, naturally, speculation follows. One persistent theory posits that these rumbles are the side effects of massive under-ice cavities shifting, similar to the sudden collapses that form the enigmatic sinkholes in the ice fields. If enormous subglacial voids exist, their walls might occasionally realign or settle, producing deep seismic signatures. Others reach further. Some theorists suggest these vibrations could be the signatures of geothermal systems, unlike any we've yet discovered, non-volcanic but capable of generating heat and motion. Perhaps even ancient energy sources buried under the ice. While there is no evidence to support such claims, researchers have documented geothermal hotspots in unexpected regions of Antarctica, raising the possibility of unknown geological processes at work. And then there are the fringe ideas. Some claim that the rumbles aren't natural at all, that they're mechanical, artificial, the result of buried infrastructure, perhaps from a forgotten epoch, or an intelligence not of this world. They cite the regularity, the recurrence, and the tonal structure of some of the signals as evidence that what we're hearing may not be Earth itself, but something operating within it. Of course, mainstream science does not support these views, but even among serious researchers, the mystery remains. What exactly is causing these unexplained rumbles? Despite years of monitoring, we have yet to locate a definitive source. Seismic triangulation is notoriously difficult on a continent like Antarctica, where distances are vast and ice distorts wave propagation. Much of the terrain remains inaccessible, and large sections of the continent have never been instrumented at all. In some regions, sensors go dark for months at a time due to weather or power constraints. What then are we missing? Could there be seismic sources we've yet to discover? Could the Earth itself be speaking in a language we have not yet learned to interpret? The answers remain hidden beneath ice older than human civilization, ice that remembers the birth of continents, the shifting of oceans, the rise and fall of climates long before we arrived. And still, it stirs. These rumbles, faint and distant, might be the last traces of ancient processes, or the first signs of something awakening, something we do not yet understand. So we listen, and we wonder. What stirs beneath the coldest, quietest continent on Earth, and will we ever hear what it's trying to tell us? As the last echoes of seismic murmurs fade into the silence beneath the Antarctic plateau, our focus shifts, not to the deep interior, but to the outermost fringe of a continent cloaked in secrecy. Here, at the edge of the East Antarctic ice sheet, where glacial flows meet the frozen sea, lies one of the least understood boundaries on Earth. It is not just the end of the land, it is the beginning of a mystery. Stretching over 5 million square miles, the East Antarctic ice sheet is the largest single mass of ice on the planet. It holds enough frozen water to raise global sea levels by more than 170 feet, and some of the ice it shelters is over 1 million years old. At its margins, the ice doesn't merely stop. It fractures, bends, and sometimes collapses into vast ice shelves that hover above the Southern Ocean like frozen wings. But it is the edge, the transition from solid land to floating ice, that has puzzled researchers for decades. To the untrained eye, this icy border appears no different from the rest of the continent, an unbroken expanse of white. But satellite imagery, radar scans, and ground-penetrating instruments have revealed anomalies here, unexpected heat signatures, strange patterns in the underlying bedrock, and, in certain sectors, abrupt vertical drops in the ice, deep crevasses that seem to appear without warning. Some of these features are consistent with natural glacial movement. The ice flows outward from the interior like syrup, spreading slowly and unevenly. But in several regions along the eastern edge, particularly near the Totten Glacier and the Shackleton Ice Shelf, the flow accelerates unexpectedly. The ice thins rapidly, and deep, subsurface channels have been found beneath the surface, channels carved not by wind or cold, but by something warmer. What lies beneath these channels? In 2016, satellite gravimetry revealed a startling discovery. Under the Totten Glacier, the land slopes far below sea level, deep enough that warm ocean currents can infiltrate hundreds of miles beneath the ice. These hidden incursions may be melting the ice from below. But that's not all the data suggests. Some researchers noticed unusual electromagnetic activity in these regions. Not strong, not dramatic, but consistent enough to warrant attention. And beneath the Shackleton Ice Shelf, magnetic mapping uncovered linear structures in the bedrock, long, straight formations that don't match the chaotic randomness of most geological features. Were they fractures, fault lines, or something else? In 1958, Soviet scientists working under the International Geophysical Year speculated about subglacial ridges in East Antarctica, raising the question of whether there could be entire systems of caverns or canyons hidden beneath the ice. Later radar surveys in the 2000s confirmed some of these features, but others remain ambiguous, visible in one scan, gone in the next. The edge of East Antarctica, unlike the more studied western regions, is more remote, more isolated, and, perhaps as a result, more prone to uncertainty. And then there is the question of the land beneath the ice. In 2018, data from NASA's Operation Icebridge uncovered several high-density regions of rock beneath the eastern ice sheet. These formations are not aligned with known mountain chains. In fact, some resemble buried plateaus, or perhaps even impact structures. One in particular, a circular mass over 300 kilometers wide, drew comparisons to known asteroid craters. Could a massive impact event have shaped the contours of East Antarctica long before the ice formed? Some geologists believe it's possible. A significant impact could have fractured the crust, altering geothermal flows and accelerating ice movement millennia later. Others suggest that the heat anomalies observed near the Totten Glacier may not be from warm water at all, but from geothermal heat rising from deep within the Earth. Yet, even geothermal theories raise questions. Why would hotspots cluster specifically near the glacial edge? Why do some of the warmest readings come from the most geologically stable part of the continent? And then there are the rumors. Among fringe theorists and alternative historians, the edge of East Antarctica holds a special allure. Some claim the sudden vertical drops in the ice are not natural, but evidence of large structures or entrances carved into the ice by unknown hands. Others suggest that ancient civilizations, perhaps from a forgotten epoch before the last ice age, once occupied parts of this land, before it was buried by snow and time. No credible evidence supports these claims, and most scientists dismiss them outright, but they persist. Perhaps because the mystery of the place is so complete. So little is known, so little has been touched. Even basic surveys are difficult here. The terrain is hostile, the weather unpredictable. Expeditions can take weeks just to reach these remote margins, and flights are limited by wind, visibility, and fuel. But the questions remain. What causes the abrupt shifts in ice flow along the eastern edge? What lies within the hidden channels and depressions beneath the glaciers? Why do certain regions generate magnetic anomalies, or seem to hide features that appear and disappear between scans? Is the edge of the East Antarctic ice sheet merely a chaotic frontier of natural forces? Or could it be concealing something older, deeper, and more enduring than we currently imagine? The answers lie buried beneath layers of compressed time and silence, beneath ice that has seen the world change over millennia and has yet to reveal all its secrets. And so, we continue to search. Because where the Earth's surface ends, mystery begins. As the glow of Erebus fades into the polar twilight, the mystery does not end. It only deepens. Far from the volcano's fiery breath, across the silent white plains of East Antarctica, a different kind of anomaly begins to emerge. It is not visible to the naked eye. It doesn't bubble or burn. Instead, it comes in the form of a whisper, faint, precise, electronic. Signals reflected from beneath the surface. Patterns that defy easy explanation. They call it SHARAD, the shallow radar instrument aboard NASA's Mars Reconnaissance Orbiter. Originally designed to peer beneath the red planet's surface, SHARAD was later adapted for use in Earth-based studies, most notably through data collected from airborne missions over Antarctica, and what it has found is perplexing. SHARAD works by sending radar pulses deep into the ice and recording the echoes that return. These reflections tell scientists about the structure of ice layers, subglacial lakes, bedrock topography, and sometimes they reveal things that shouldn't be there. It began innocently enough. In 2006, early SHARAD tests over the Antarctic ice sheet picked up what seemed to be a highly reflective horizontal interface buried deep beneath the surface, nearly 2 miles under in some cases. Scientists assumed it was liquid water, trapped in a subglacial lake, similar to the now famous Lake Vostok. But the readings weren't quite right. Instead of a smooth echo typical of water beneath ice, SHARAD began returning complex, sharply defined patterns, gridded structures, repeating anomalies, and signal distortions that didn't match the known behavior of rock, sediment, or water. Were these simply glitches in the radar? Misreadings caused by unusual ice conditions? That was the initial theory. But then they started to repeat, over different flights, under different conditions, across different locations. Some echoes seem to suggest vast, flat surfaces more reflective than expected. Others appeared to reveal subsurface formations with near-perfect angular symmetry, rectangular zones, buried ridges, and voids that formed shapes too geometric to ignore. Could these be natural geological features formed by ancient tectonic activity? Or were scientists glimpsing something entirely unexpected, something buried? The mainstream view remains cautious. Many researchers argue that ice layering, brine saturation, or unusual mineral content could be responsible for the echoes. It's true that Antarctic ice behaves strangely under pressure, and its deep layers often contain frozen relics of past climate cycles, dust, ash, even microbial life. But not everyone is convinced these explanations suffice. One of the most famous radar anomalies lies beneath Wilkes Land in East Antarctica, a region long suspected of hiding a massive impact crater over 300 miles wide. SHARAD and gravimetric data have revealed a mass concentration beneath the ice, far denser than surrounding areas. This mascon, as it's known, resembles those found beneath lunar craters created by ancient asteroid strikes. Could this be evidence of an impact so massive that it reshaped Earth's climate, or even ended the Permian period over 250 million years ago? If so, it might explain some of the radar echoes, but not all. Further to the south, other SHARAD echoes have uncovered anomalies that lack any clear geological precedent. Some researchers quietly refer to them as non-natural interfaces. In other words, structures that, at least in radar form, look engineered. Here, speculation begins to swirl. Some theorists have posited that the echoes may be remnants of lost civilizations, perhaps even pre-glacial human activity erased by time and ice. Others suggest the radar may be bouncing off exotic mineral formations, meteorite fragments, or ancient volcanic structures altered by intense pressure. Then there are those who go further, much further. Fringe theories claim these echoes reveal the edges of vast subterranean facilities, alien in origin, or even remnants of ancient advanced technology long buried beneath the Antarctic crust. They point to the suspicious geometric qualities of the radar returns: sharp angles, uniform spacing, grid-like boundaries. And yet, no drilling expedition has reached these depths in the exact locations of the anomalies. The ice is simply too thick, the terrain too inaccessible, the environment too extreme. For now, we are left with only the radar, a ghostly signature beneath the frozen miles, a signal that reflects but does not explain. What's perhaps most haunting is the silence that surrounds these findings. Unlike more publicized mysteries like subglacial lakes or ice shelf collapses, the strange echoes recorded by SHARAD are rarely discussed outside specialized scientific literature. They are not secret, but they are quiet. Why? Is it simply that they fall beyond the realm of current understanding, too ambiguous to merit sensational attention? Or is there more to the story? As SHARAD and similar instruments continue to scan the ice sheet, the anomalies persist. Their shapes repeat. Their signals remain sharp, and their interpretations continue to evade consensus. What lies beneath the Antarctic ice? An asteroid impact? A hidden ecosystem? A trick of radar physics? Or something far more unexpected? The echoes wait, deep in the silence, reflecting back our signals like a mirror from a forgotten past, or perhaps from something that never made it into the history books at all. The mystery remains unsolved. And in Antarctica, that silence often means we've only just begun to listen. And so the radar pulses fade, echoing across time and ice. Yet even as one mystery sinks beneath the snow, another rises, half seen, half buried, into view. To the east of the vast Antarctic continent lies a region almost entirely untouched by human presence, Princess Elizabeth Land. It is remote even by Antarctic standards, a silent expanse of wind-blasted ice and snow, lying far from the nearest research stations, with brutal weather that often renders satellite imagery incomplete or distorted. But beneath this sheet of ancient ice lies something unexpected. A mountain range, long, jagged, and unseen by human eyes. They call them the Gamburtsev Mountains. But in recent years, another name has quietly surfaced: the Ghost Mountains. Why? Because they are real, measurable, massive, and yet they remain invisible. Discovered not by sight, but by the pulse of radar and seismic soundings during the International Geophysical Year of 1957, the Ghost Mountains stretch for over 750 miles beneath the central East Antarctic ice sheet. Some peaks are believed to rise over 10,000 feet, comparable to the Alps. But despite their size, no one has ever stood on them. No photograph has ever captured their form. They lie entombed beneath up to 2 miles of solid ice, and yet their existence is undeniable. It begs a question: what are mountains doing here, hidden beneath one of the coldest, flattest, and oldest ice sheets on Earth? The mainstream explanation begins with geology. Scientists suggest that the Gamburtsev Range formed around 1 billion years ago, during a massive continental collision. Over time, they eroded and were buried by sediments. Then, some 35 million years ago, as Antarctica drifted south and the climate cooled, ice began to accumulate, slowly encasing the range in its frozen tomb. That's the accepted theory. But there's a problem. The mountains are too sharp. Radar imagery and seismic data suggest that many of the peaks have retained their rugged alpine structure: ridges, valleys, and steep inclines, not the worn-down, rounded forms one would expect of a billion-year-old range. Some geologists have even noted features that resemble recently carved fjords, raising the possibility that flowing water, perhaps meltwater rivers beneath the ice, may still be shaping them. Others go further. Some researchers propose that the mountains are not as ancient as once thought. Could they have formed more recently, perhaps during a geologically younger tectonic upheaval? If so, why are there no matching surface features elsewhere on the continent? And then there are the anomalies. Beneath Princess Elizabeth Land, scientists using gravimetric and magnetic data have detected localized disturbances, regions of unexpected density, magnetic field variation, and unusual reflectivity. Some of these distortions lie near the base of the Ghost Mountains, clustered in ways that suggest structure. But what kind of structure? Subglacial lakes? Volcanic formations? Or something that doesn't yet fit into known geological models? It was in 2009, during the collaborative Antarctic Gamburtsev Province Project, AGAP, that international researchers mapped much of the subglacial terrain in exquisite detail. They found something startling. Beneath the surface ice, the landscape is not just mountainous, it is highly organized. Basins, plateaus, channels, even features that resemble terraces or artificial-looking contours. Could this be nature's own architecture, sculpted by pressure and time? Or are we glimpsing something older, and perhaps no longer natural? The mystery has not gone unnoticed in speculative circles. Fringe theorists have suggested that the Ghost Mountains could hide far more than rock and ice. Some point to ancient myths of lost continents, Hyperborea, Lemuria, even remnants of early human civilization wiped clean by glaciation over 12,000 years ago. Is it possible that Princess Elizabeth Land was once above the ice? That its peaks may have once touched the sky, inhabited, traveled, perhaps even mapped in a time before modern memory? It's a seductive thought, but mainstream science remains cautious. No evidence, no artifacts, no ruins, no anomalies beyond radar echoes has confirmed any such claim. And yet, the radar returns persist. The gravimetric disturbances remain unresolved, and access to the region is limited at best. Few have overflown it. Fewer still have attempted to land anywhere nearby. Logistically, Princess Elizabeth Land is almost unreachable. Politically, it is sensitive, lying within Australia's claimed Antarctic territory, subject to the strict protocols of the Antarctic Treaty. No independent drilling has occurred near the Ghost Mountains, and the region remains one of the least explored places on Earth. For now, the secrets of the range lie locked beneath a million years of silence. But that silence speaks volumes. What else lies beneath the ice? What hidden chapters of Earth's history are entombed there, their records preserved in cold, crystalline time? And why do the echoes that return to us from radar, from seismic waves, from magnetic field anomalies, carry such strange and stubborn whispers? In a land where nothing should move, we find rifts that split overnight. In regions thought to be dead, we detect volcanic warmth. And now, in the heart of Princess Elizabeth Land, we see mountains that no one can climb, but that nonetheless cast a long, unseen shadow across the scientific landscape. The Ghost Mountains are not merely a geological curiosity. They are a mirror, reflecting how little we truly know about our own planet. And in that reflection, we must ask, if these massive peaks could remain hidden for so long, what else lies just beneath the surface, waiting to be revealed? Beneath the spectral outline of the Ghost Mountains, where radar pulses trace the contours of peaks that no human eye has seen, the mysteries deepen, layer upon layer, into the ice. The questions shift from what stands above the bedrock to what flows quietly below. In 2022, a team of geophysicists made a discovery that reverberated through the scientific world, though few outside the field may have heard of it. Using sophisticated electromagnetic sensors and ice-penetrating radar, they revealed evidence of a vast freshwater aquifer trapped deep beneath the Wilkes ice stream in West Antarctica. It was not a lake, not a pond sealed beneath ice. It was something stranger. A sponge-like matrix of liquid water, soaked into deep, porous sediment, stretching for hundreds of kilometers and possibly containing more water than all the subglacial lakes in Antarctica combined. The aquifer lies under about a kilometer of solid ice, and yet it moves. Not fast, not on the surface, but deep below, slow currents may be pulsing through it, shifting, reshaping, and perhaps even feeding into subglacial river systems that remain poorly understood. Why is there fresh water here? And how has it remained liquid in one of the coldest environments on Earth? The answer, scientists believe, lies in pressure and geothermal heat. At extreme depths, the weight of the overlying ice raises the melting point of water. Add in heat radiating from Earth's interior, and a thin layer of warmth begins to form. Not enough to melt the ice above, but just enough to keep the sediment waterlogged. It's a delicate balance, one that, if altered even slightly, could have dramatic consequences. This hidden aquifer may serve as a lubricant, easing the flow of massive glaciers above. It may act as a reservoir, releasing or absorbing meltwater in response to pressure changes. It may even connect to other hydrological networks beneath Antarctica, forming a vast, unseen plumbing system that slowly drains or floods with the rhythms of a frozen world. But even as the scientific models evolve, questions linger. How long has the aquifer been there? Is it stable? Does it change over time? Or pulse with seasonal or seismic activity? And perhaps most intriguingly, what does it contain? In recent years, studies of other subglacial environments, such as Lake Wilkes and Lake Vostok, have shown signs of life. Extremophiles, microbial communities adapted to complete darkness, high pressure, and extreme cold. Could the aquifer, with its enormous volume and porous environment, serve as a vast subterranean biosphere? Could life be thriving in complete isolation, evolving independently for millions of years? If so, what might it look like? And if microbial life can persist beneath Antarctica's ice in such an alien environment, what might that imply for similar sub-ice oceans elsewhere, on Europa, Enceladus, or other icy moons of the outer solar system? These aren't just abstract comparisons. NASA and ESA researchers have studied Antarctica's subglacial lakes and aquifers precisely for their analogs in outer space. The conditions here may offer the closest earthly parallel to oceans that lie beneath extraterrestrial ice. But the questions aren't limited to biology. Geologists have speculated that the aquifer might store ancient water, melted from snow that fell before the last ice age, or even earlier. Could it hold trapped gases, ancient DNA, chemical signatures of long-lost atmospheric conditions, or even something else? There are more speculative voices, quiet ones, often whispered at the edge of scientific conferences. Some suggest that the aquifer and other liquid water bodies below the ice could connect to vast cavern systems, like those hinted at near Mount Erebus or Princess Elizabeth Land. That deep tectonic fractures and geothermal vents might shape more than just sediment. They might carve out hollow, shielded realms beneath the ice. A few even point to anomalies in satellite gravity maps, regions where mass is missing or redistributed in patterns that don't entirely match expected geological structures. Could it be that some of Antarctica's subglacial water doesn't just sit beneath the ice, but flows through it? Does it move between layers, rise and fall with geothermal pulses, or vanish entirely into unknown voids? For now, such thoughts remain hypothetical. The aquifer cannot be drilled, not easily. Its depth and remoteness make direct study almost impossible. The electromagnetic surveys that revealed it can only hint at its shape and size, not its contents. And yet, it is there. A massive, slow-moving sea beneath the most frozen place on Earth. Its presence challenges our understanding of ice, water, and time. It forces us to ask how dynamic, how alive Antarctica truly is, not on the surface, but in its shadowed depths. If we've only just discovered this aquifer now, what else might lie hidden in the dark, under thousands of feet of silence? What pulses beneath the ice when no one is watching? And what secrets, frozen in time, might one day rise from these cold and buried waters? As we rise from the veiled depths of Antarctica's subterranean waters, our attention drifts upward, beyond the glaciers, past the jagged peaks of Queen Maud Land, and into the frigid stillness of the polar stratosphere. Here, above a continent locked in perpetual ice, unfolds a riddle of the sky, a phenomenon invisible to the eye, yet critical to life on Earth. For decades, Antarctica was synonymous with a gaping wound in our planet's atmosphere, the ozone hole. Each austral spring, a swath of the stratosphere above the southern continent would thin dramatically, pierced by sunlight interacting with man-made chemicals, primarily chlorofluorocarbons, CFCs. The hole, first identified in the early 1980s, became a global symbol of ecological danger and international response. It spurred the Montreal Protocol of 1987, hailed as one of humanity's most successful environmental treaties. Year after year, satellites tracked the ozone hole's growth, its peak, and its eventual shrinkage. By the early 2000s, scientists began to note signs of gradual healing, a slow, expected decline in the size and severity of the seasonal anomaly. And then, something strange happened. In 2019, scientists recorded an unusually small ozone hole, one of the smallest since the 1980s. The following year, 2020, was different again. An exceptionally long-lived and persistent ozone hole that refused to close on schedule. In 2021, it grew large once more. Then, in 2022, another sharp decrease. By 2023, it had nearly vanished mid-season, but only briefly. These irregularities sparked quiet but serious concern. What had once been a fairly predictable pattern now seemed to fluctuate in ways that didn't fully align with chemical models or policy timelines. While most scientists attributed the fluctuations to natural variability, such as changes in stratospheric temperature, polar vortex strength, and solar activity, others began to wonder, was something else interfering with the healing process, or accelerating it, unexpectedly? The ozone layer's delicate chemistry is sensitive to a wide range of influences. Volcanic eruptions, for instance, can inject sulfur aerosols into the stratosphere, altering chemical reactions. Likewise, cosmic radiation and changes in the sun's ultraviolet output may play a role. But none of these fully explain the sudden disappearances. Short-lived but sharp reductions in ozone depletion where anomalies should have persisted. Could there be other forces at work in Antarctica's atmosphere? Some scientists point to climate feedback loops, how warming oceans and shifting jet streams may be affecting polar circulation in unexpected ways. Others explore the role of stratospheric water vapor, which has been increasing for reasons not yet fully understood. Could methane, rising from thawing permafrost or sub-ice sources, be a factor? Might greenhouse gases be altering temperature profiles in ways that modify ozone chemistry indirectly? And then there are more speculative possibilities, whispers that fall outside the traditional frameworks of atmospheric science. Over the years, some researchers have quietly questioned whether geophysical anomalies under Antarctica, such as geothermal hotspots or even magnetic disturbances, could subtly influence upper atmospheric conditions. These ideas remain largely unproven, and yet they persist. More fringe theories abound, suggestions that certain satellite systems, ionospheric heaters, or unknown atmospheric technologies could alter the behavior of the stratosphere over specific regions. While there is no verified evidence of such interventions over Antarctica, the curious timing and geographic specificity of the ozone irregularities continue to spark inquiry. Why do the anomalies focus so tightly above the southern polar region? Why, in an environment already among the most isolated and controlled on Earth, do we continue to see unexpected behavior in a process we believed we had fully understood? To this day, scientists monitor the ozone hole with high-precision instruments, spectrometers on satellites, balloons launched into the stratosphere, ground-based observatories perched on the Antarctic Plateau. And yet, even with all our tools, the atmosphere guards its secrets well. Is the healing ozone layer a triumph of human coordination, or a fragile equilibrium still poorly understood? Could unseen processes, deep within the planet or high above it, be influencing patterns we can barely detect? And perhaps most haunting of all, what happens if the ozone layer does not return to its previous state? Not because of continued pollution, but because something fundamental about Earth's atmospheric system is changing, or has already changed. The sudden disappearance of ozone anomalies above Antarctica is not, by itself, a catastrophe, but it is a whisper, subtle, persistent, unsettling. A signal that the polar skies, like the ice below, hold mysteries that defy simple answers. And if something so vital, so carefully watched, can still behave in ways we don't expect, what else might be unfolding in this quiet, frozen world? What other signs in the skies above Antarctica are we still learning how to read? As we descend once more from the mysteries of the sky, the vast silence of the Antarctic continent welcomes us back, not with noise, but with stillness. Ahead, the Transantarctic mountains rise in sharp defiance of the endless ice, their peaks cutting through the glacial plain like fossilized waves in a frozen ocean. Stretching over 2,000 miles, these rugged spines of ancient rock divide East and West Antarctica, forming one of the longest mountain ranges on Earth. Winds here scream across barren ridges, sculpting the exposed rock into jagged relief. Snow collects in hidden alcoves, while glacial sheets creep slowly year by year, like time itself moving through stone. Yet it is beneath this cold, desolate exterior that a revelation waits. Here, locked in the sedimentary layers of these mountains, trees have been found. Not petrified wood, as might be expected in fossil-rich terrain, but actual remnants, stumps, roots, and even tree rings, astonishingly well preserved by Antarctica's cold, dry climate. Ancient forests, buried not in myth, but in stone. How can this be? In a place where modern temperatures rarely rise above freezing and life exists only in the most extreme niches, the idea of towering trees, some possibly resembling modern conifers, feels deeply out of place. Yet scientists have uncovered evidence of rich vegetation dating back 250 to 280 million years, to a time when Antarctica was not a land of ice, but one of lush forests and flowing rivers. It was the Permian period, before the rise of the dinosaurs. Antarctica, then part of the supercontinent Gondwana, lay closer to the equator and enjoyed a milder, humid climate. Fossilized leaves, bark impressions, and entire root systems suggest a dense canopy of ancient species, many long extinct, blanketed the land. The most compelling of these finds were not just impressions or coal beds, but standing tree stumps still rooted in the ground, some measuring more than 2 feet in diameter. Found near Mount Aquifer and other areas of the central Transantarctic range, these remnants are so intact that growth rings can be studied in detail, offering rare insight into prehistoric climate cycles and seasons. But the mystery does not end with simple prehistoric botany. One question lingers. How did these forests survive in regions that, even during warmer periods, would have experienced months of total darkness each year? Even if the Earth's climate was once radically different, polar latitudes would still have been subject to extreme photoperiods, 6 months of daylight followed by 6 months of night. Did these ancient trees possess adaptations unknown in today's flora, mechanisms to photosynthesize in near-total darkness or enter long, dormant phases? Were atmospheric conditions so dramatically different that they enabled growth under twilight skies? Some researchers speculate that elevated levels of carbon dioxide during the Permian may have helped trap more solar heat, creating subtropical conditions even at high latitudes. Others suggest that the Earth's axial tilt may have shifted over time, reducing seasonal extremes. But none of these theories fully explain the level of preservation or the location of these trees, sometimes found deep within the interior of the continent, where even the idea of past warmth strains belief. And still, stranger possibilities surface. Could parts of Antarctica have remained temperate for far longer than mainstream geology suggests? Some fringe theorists claim that ancient civilizations, possibly lost, may have existed here before the last ice age, basing their ideas on distorted interpretations of these preserved trees and rare geological anomalies. While there is no concrete evidence supporting such claims, the mere presence of large, forest-dwelling plants in the heart of Antarctica fuels imagination. Others look to cataclysmic events. Might the shifting of tectonic plates or sudden changes in the Earth's crust, such as those proposed by proponents of Earth crust displacement theories, have altered Antarctica's position or climate more rapidly than we understand? If so, could entire ecosystems have been flash frozen, preserved in conditions that defy conventional timelines? These ideas remain outside accepted science. And yet, the undeniable reality of the trees themselves, a forest under the ice, invites a quiet wonder. Each ring in those ancient stumps tells a story, of sun and shadow, of warmth and cold, of a world before ours. They are reminders that Antarctica has not always been silent, that beneath its wind-swept plains and glacial peaks lies the memory of life, vibrant, green, and reaching toward a sun long set. So what else lies preserved in the frozen heart of this continent? Are there deeper layers, undiscovered forests, or perhaps other forms of life, still waiting to be uncovered by the slow grind of ice or the patient hands of science? And if trees once thrived where now only stone and snow remain, could it happen again? Or was that forest a singular chapter in Earth's distant past, one we glimpse only briefly through fragments of root and bark left behind in the coldest place on Earth? As we leave behind the silent witness of ancient forests preserved in Antarctic stone, the journey draws us eastward, beyond mountain ranges, over endless white deserts, and into the heart of one of the most isolated research outposts on Earth. Here, at nearly 75 degrees south latitude and perched more than 3,000 meters above sea level, Dome C sits atop the East Antarctic ice sheet like a sentinel. Flat, featureless, and relentlessly cold, the landscape surrounding this remote site is so pristine that even the wind seems hesitant to disturb it. The temperature regularly drops below minus 80 degrees Fahrenheit. There are no signs of life, no movement, only the deep hum of the earth beneath, and occasionally something else. It was at this very location, chosen for its extreme atmospheric clarity, that scientists began to notice something odd. Instruments meant to measure radio waves, atmospheric particles, and cosmic background radiation began experiencing anomalies, subtle, persistent, and not easily explained. These were not isolated glitches, but recurring disruptions, irregular spikes in data, and untraceable electromagnetic interference occurring at seemingly random intervals. Over time, researchers grew familiar with the phenomena, even if they could not account for its origin. Could these readings be dismissed as technical malfunctions? Or was something deeper resonating beneath the surface, something not entirely understood? Dome C, officially known as Concordia Station, is jointly operated by French and Italian research agencies. Its primary function is to serve as a platform for climatology, glaciology, astronomy, and human physiological studies. The site's high elevation and isolation make it ideal for observing the upper atmosphere and cosmic radiation without much terrestrial interference. But that same isolation also makes it a uniquely vulnerable listening post, exquisitely sensitive to anomalies that might be imperceptible elsewhere. One early theory attributed the strange interference to ionospheric disturbances, the result of high-energy particles from solar flares disrupting Earth's magnetic field. This explanation is supported by known science. The polar regions are particularly susceptible to these interactions, as Earth's magnetic lines converge near the poles, funneling solar activity into the upper atmosphere. Could these electromagnetic anomalies simply be exaggerated echoes of solar weather? Perhaps. And yet, not all disturbances neatly align with solar events. Some interference has been recorded during periods of low solar activity, with waveforms inconsistent with known space weather patterns. Moreover, the signals sometimes appear to pulse, brief, rhythmic fluctuations resembling patterns one might expect from man-made sources, yet occurring in a location far from any industrial activity. This raises another question. Could the interference be terrestrial in origin, caused by unknown geological or geophysical processes under the ice? Beneath Dome C lies one of the thickest sections of the Antarctic ice sheet, reaching depths of nearly 300 meters. Below that, ancient rock formations have remained untouched for millions of years. Could slow tectonic stresses or unknown subterranean features be emitting low-frequency electromagnetic fields? Some geophysicists suggest that deep crystalline structures, fault lines, or even trapped underground fluids could generate such effects under extreme pressure. Still, others look beyond conventional explanations. Fringe theories have long speculated about the existence of hidden structures buried deep under Antarctica's ice, possibly remnants of ancient civilizations or even extraterrestrial technologies. These claims are often accompanied by grainy satellite imagery and unverified testimonies, but the electromagnetic irregularities observed near Dome C have sometimes been invoked in support of such ideas. One of the more persistent theories links the region to Operation High Jump, the U.S. Navy's Antarctic expedition in 1946-47, which some believe was motivated by more than just military training and cold weather survival exercises. According to these speculative accounts, there were efforts to investigate anomalous readings and recover unidentified objects. While the historical record offers no definitive evidence for such claims, the mystery surrounding Dome C's interference continues to draw attention from researchers, both mainstream and alternative. Adding to the intrigue is the station's proximity to Lake Vostok, another enigmatic Antarctic feature. Though located hundreds of kilometers away, the fact that both areas lie atop unusually active geophysical zones has prompted questions. Could there be a connection between these anomalies and the presence of subglacial lakes thought to be sealed off from the atmosphere for millions of years? If strange electromagnetic patterns are emerging from beneath the ice, could they be tied to microbial or geothermal processes unknown to current science? Or is something else, something not yet imagined, responsible for the signals? Despite years of study, scientists still struggle to pinpoint a definitive cause. The interference doesn't always follow predictable patterns. It doesn't correlate neatly with known geomagnetic indices. And unlike typical terrestrial radio noise, it appears at frequencies rarely disturbed in such an isolated location. It is possible, perhaps even likely, that a convergence of natural factors explains the mystery. Ionospheric refraction, glacial strain, solar cycles, and the extreme sensitivity of modern instruments. But the puzzle remains unsolved, the data still dotted with unanswered questions. What is producing the silent flicker across these polar frequencies? Could these be early signs of natural processes still undiscovered by science? Or do they point towards something buried, waiting beneath kilometers of ice, something that resists easy categorization? As the Antarctic night closes in once more, and Dome C returns to months of shadow and stillness, the instruments continue to listen. And in the depths of that frozen silence, one cannot help but wonder, what else might be whispering through the static? As we leave the silent, flickering mysteries of electromagnetic echoes above Dome C, our attention is drawn upward, into the wide and often overlooked airspace over Antarctica. A place where silence reigns not only on the ground, but in the skies above. Because curiously, some areas of this frozen continent are off-limits to flight. In a region so vast, so remote, and so devoid of population, one might expect unrestricted air travel to be the norm, especially for research and supply missions. But the reality is more complex. Scattered across the Antarctic map are zones where aircraft are either prohibited from entering or where flight is tightly restricted. These so-called no-fly zones have sparked questions for decades. Questions that, to this day, remain difficult to fully answer. The most commonly cited reason is safety. Antarctica is home to some of the harshest flying conditions on Earth. Sudden storms, fierce katabatic winds, and near-zero visibility can emerge in minutes. Combine this with a lack of emergency infrastructure, and it's easy to understand why flight routes are carefully regulated. International treaties, primarily the Antarctic Treaty System, also impose strict environmental guidelines, limiting human activity to preserve the fragile ecosystem. Yet some of these no-fly areas lie in places where those standard explanations begin to fray. Take, for instance, the region surrounding Mount Erebus, the southernmost active volcano on Earth. Aircraft are often instructed to avoid this area, not just because of the potential for volcanic ash, which is rare, but due to electromagnetic interference and unpredictable atmospheric conditions, many of which are still under study. pilots have occasionally reported navigation instruments becoming unreliable when flying nearby. Could this be related to the same anomalies recorded over Dome Sea? Or is something more concealed beneath the ice? Farther inland, near Vostok Station, lies another no-fly zone, this one hovering above one of the most enigmatic features of the continent, Lake Vostok, a subglacial body of fresh water hidden under more than 2 miles of ice. Scientists believe this lake has been sealed off from the surface for over 15 million years. When early radar scans of the region returned unusually flat, reflective signatures, almost metallic in appearance, some theorized the presence of artificial structures. These claims have never been substantiated, but restrictions on overflights in the area have only intensified speculation. Of course, the official explanation is simple: protection of delicate scientific research. Overhead flights can interfere with sensitive instruments measuring magnetic fields, radiation levels, and microclimate conditions. Jet exhaust and vibration can also disrupt the pristine isolation required for paleoclimate ice core drilling. And there's truth in this. Research stations like Concordia, Dome Fuji, and the Amundsen-Scott South Pole Station all rely on low-disturbance environments to produce accurate scientific data. But the story doesn't end there. One particularly strange incident dates back to 1947, during Operation High Jump, a large-scale U.S. Navy expedition to Antarctica. While officially tasked with testing military equipment and conducting research, rumors quickly circulated that something unexpected had been encountered. According to declassified but ambiguous reports, certain flight paths were suddenly altered mid-mission, and a handful of aircraft were diverted away from zones marked restricted with little explanation. In later years, a few former personnel made unverified claims that these areas contained unusual topographical features: sharp geometries, circular depressions, even structures partially visible through satellite imaging. Though most mainstream historians dismiss these as fabrications or misinterpretations, others question why some of the same zones remain inaccessible even today. Consider also Wilkes Land in East Antarctica, where satellite gravity measurements have revealed a massive mass anomaly beneath the ice, something dense, wide, and very deep. Speculation has ranged from a giant asteroid impact crater to ancient continental crust trapped in an unusual way. The U.S. Geological Survey downplays the anomaly, but curiously, Wilkes Land also lies beneath a region where flight activity is unusually sparse. Could these restrictions be related to what lies beneath? Another layer of mystery stems from the fact that many modern aircraft equipped with highly sensitive radar systems and GPS guidance are automatically programmed to avoid certain coordinates over Antarctica, even on autopilot. While this is typically dismissed as the result of flight planning software accounting for poor signal reception and terrain, some wonder, if there's nothing to hide, why not open these areas to broader investigation? One fringe theory even posits the existence of underground bases, a relic of Cold War paranoia and conspiracy lore. According to these narratives, nations with vested interests in Antarctica's strategic and scientific importance might have created hidden facilities to study or conceal what lies under the ice. Supporters of this theory often point to redacted documents, abrupt flight diversions, and inconsistencies in air traffic data. Skeptics counter that these are the ordinary hallmarks of a place where safety, not secrecy, dictates policy. Still, the questions persist. In a world where commercial aircraft crisscross nearly every inch of the globe, why are certain paths in Antarctica still off-limits? Why do military craft operating near the continent sometimes go radio silent without explanation? And why are satellite images of these zones occasionally blurry or obscured, even in an era of ultra-high-resolution mapping? The Antarctic Treaty was signed in 1959 to preserve the continent for peace and science. And yet, decades later, much of Antarctica remains untouched and unseen. Perhaps it is simply caution that dictates these blank spots on the aviation map. Or perhaps, as some suggest, these airspace restrictions serve to keep something else beneath the surface, something not meant to be found. As the polar winds sweep across the ice, as empty skies stretch over a continent few have truly explored, the silence above Antarctica speaks just as loudly as its secrets below. What then might lie hidden beneath these flightless skies? And who, if anyone, already knows? As aircraft veer away from designated no-fly zones, tracing safe corridors through the southern sky, one region lies just beyond the reach of regular aviation routes. It stretches for hundreds of miles, flat, featureless, and untouched. Beneath a sky that appears closer than it should, the Antarctic Plateau begins. At over 10,000 feet above sea level, the plateau forms the vast, frozen heart of Antarctica. It is the coldest, driest, and most desolate expanse on Earth, a place so hostile, even sound seems reluctant to linger. The air is thin and bitter. Temperatures can plunge below 130 degrees Fahrenheit. The wind, oddly, is often still, and in that stillness, a deeper kind of silence settles, one that's been described not merely as the absence of sound, but the presence of something else, something more elusive. Researchers stationed at Dome A, Dome Fuji, or the Amundsen-Scott South Pole Station speak of it with quiet reverence. The uncanny, complete stillness of the plateau. No birds, no trees, no flowing water. Not even the crack of distant icebergs. Just an endless white plain under a sky of pale blue, as if the land itself is holding its breath. But what does it mean for a place to be this quiet? From a scientific standpoint, the Antarctic Plateau is a marvel. Its dry, stable air makes it ideal for astrophysical research. Telescopes positioned here can peer deep into the cosmos with minimal atmospheric interference. Its layered ice holds within it a frozen record of Earth's climate going back hundreds of thousands of years. And the sheer remoteness of the region offers a rare glimpse into Earth's natural rhythms, undisturbed by the noise and chaos of civilization. But as with so many aspects of Antarctica, what we don't know may rival what we do. In the early 2000s, seismic listening devices placed across the plateau began recording something unusual. At first, it seemed like a glitch, random, low-frequency pulses that echoed up through the ice from below. Not strong enough to be earthquakes, not rhythmic enough to be from glaciers, just soft, persistent signals. Faint rumbles, like whispers moving through stone. Geophysicists suggest these could be cryoseisms, sometimes called frost quakes, subtle fractures that occur when extreme cold causes sudden movement within layers of permafrost. Others believe the signals may originate from the slow grinding motion of the Antarctic tectonic plate. Still others theorize they're the product of atmospheric pressure waves funneling down into the ice, producing vibrations that mimic seismic activity. And yet, none of these explanations seem to fit all the data. The signals don't always correlate with weather events. They occur too deep in the crust to be entirely atmospheric in origin. And unlike typical geological processes, their timing and intensity seem inconsistent, as if something beneath the ice is shifting in ways we do not fully understand. Then there's the question of silence itself. In most places on Earth, absolute silence is unattainable. Ambient noise caused by wind, water, wildlife, or human industry creates a constant hum in the environment. But on the Antarctic Plateau, sound doesn't behave the same way. The dry, dense cold suppresses sound waves. Vibrations are swallowed by snow. Even footsteps become muffled and surreal. Instruments designed to measure the Earth's background noise find unusually low readings here, revealing gaps of sound so pure they're used as baselines for deep space signal testing. It's in this environment, utterly still, utterly quiet, that some researchers claim to have experienced sensations difficult to describe, a sense of being watched, feelings of disorientation, auditory hallucinations. These are often attributed to psychological stress, the effects of isolation, or the disorienting monotony of the landscape. But a few have suggested something else, that the silence itself may be exerting a kind of pressure, that in the absence of external noise, the mind begins to reach into other registers, imagining or sensing what may or may not be there. This idea has fed more speculative theories. Some propose that the plateau's unnatural stillness could be masking more active phenomena beneath the ice. Ancient caverns warmed by geothermal heat, subglacial lakes harboring microbial ecosystems cut off from the surface for millions of years, or even hollow spaces created by the natural arch of the continent's buried mountains, spaces large enough to distort electromagnetic readings or dampen seismic waves in ways not yet fully modeled. Others go further. They suggest the Antarctic plateau's quiet isn't just natural, but intentional. That certain areas have been kept off limits, not to preserve science, but to preserve secrecy. Rumors from the Cold War era whisper of long-forgotten installations buried in the ice, abandoned, perhaps, or still operating in shadow. Satellite images of the interior occasionally show geometric patterns, straight lines, and shapes that nature does not typically create. Most are later explained as compression artifacts or sensor anomalies, but not all. Could it be that the silence is more than environmental? Could the absence of sound be hiding something? A few point to the electromagnetic anomalies recorded over Dome Sea, or the gravity shifts detected near Wilkes Land, as clues in a larger pattern. A pattern suggesting that the Antarctic plateau may be more dynamic and more mysterious than we've allowed ourselves to believe. Yet no definitive answers have emerged. The silence holds. The snow does not speak, and the ice keeps its secrets. It is here, amid the untouched white, that the human imagination stirs, filling in the void with wonder, doubt, and questions science has not yet been able to resolve. What is it about this place that feels different? And in a world so thoroughly mapped, so constantly observed, why does the Antarctic plateau remain one of the few places where silence still reigns, and where mystery still survives? The silence stretches on, unbroken, as we move eastward, beyond the heart of the plateau, toward the rugged, ice-buried flanks of Queen Maud Land. Here, the wind picks up again, brushing across jagged mountain peaks that stab through the glacial surface like the spines of a sleeping beast. This region, named by Norwegian explorers in honor of their queen in the early 20th century, offers a rare glimpse into Antarctica's raw and mountainous underbelly. From above, satellite imagery captures a jagged line of nunataks, exposed ridges and summits, surrounded by the flowing white of ancient glaciers. But it is not the surface that stirs the deepest curiosity. It is what lies beneath. For decades, researchers have been mapping Antarctica's hidden world using radar, seismic imaging, and gravity measurements. These technologies allow us to peer beneath the miles-thick ice and reveal contours no human eye has ever seen. In most regions, this data forms a reasonably coherent picture: buried valleys, ancient lake beds, and fault lines carved into the crust. But near Queen Maud Land, something odd emerges, something that has yet to be fully explained. Amid the ice sheet's thick layers, radar echoes bounce back with strange gaps, hollows, and narrow channels. These anomalies appear in repeating patterns, long, winding voids that twist deep into the subglacial terrain. Scientists describe them as tunnel-like features, though not officially labeled as such. They are elongated and relatively consistent in shape, stretching for miles beneath the surface, often branching like roots beneath a tree. Some are theorized to be ancient water channels, remnants of a time when meltwater flowed beneath the ice, carving pathways through softer rock. Others may have formed more recently, created by pressurized subglacial rivers still flowing in the dark today. And yet, their scale and symmetry raise questions. Some appear too uniform, too structured, to be entirely natural. Could there be more to these tunnels than geology? Historical records offer curious context. In the 1930s, a German expedition to Queen Maud Land, led by Alfred Richer, mapped the region from the air and claimed vast stretches of territory, naming it Neuschwabenland. Their mission, while framed publicly as scientific, was shrouded in secrecy. Some of the aircraft were equipped with warm air dispersal devices meant to melt small sections of ice, an odd choice for an aerial mapping effort. Photographs and reports from the time hint at interest in specific, isolated valleys later found to lie near areas with unusual subglacial topography. Of course, many of these early documents were lost in the war years that followed. Others remain classified, and into that vacuum of information, a fog of speculation has crept. One fringe theory suggests that these tunnels, if they are indeed tunnels, could have been enlarged or repurposed, not by natural processes, but by design. Proponents of this view point to consistent dimensions, turns that seem engineered, and unexpected intersections where multiple channels converge. They ask, if nature carved these paths, why are they so geometrically regular in some cases? Why do they echo forms more commonly seen in architecture than geology? Skeptics argue that these theories misrepresent the data, that radar shadows and imaging artifacts are being misunderstood or exaggerated, that glaciers are capable of carving complex, even structured features, especially over millions of years. And they may be right. But the mystery endures. Adding to the intrigue is the lack of ground-level exploration in these areas. Unlike other parts of Antarctica, where scientific drilling has sampled lakes and ice cores, the subglacial regions beneath Queen Maud Land remain largely untouched. The cost, danger, and international treaties governing the continent have ensured that no major drilling campaigns have reached the deepest parts of this area. What lies within the tunnels, if anything, remains entirely unknown. Yet some evidence hints that they may not be entirely empty. In recent years, satellite thermal imaging has revealed faint anomalies, slight temperature elevations, in the ice above several tunnel-rich zones. These hotspots could be due to geothermal activity, a logical explanation given Antarctica's volcanic history. But in at least one case, the thermal pattern was unusually narrow and linear, as if heat were rising not from a diffuse source, but from a distinct underground structure. Are these simply natural formations, carved by water and pressure, warmed by the Earth's crust? Or are we glimpsing the remnants of something older, perhaps even man-made, preserved beneath the ice since a time long forgotten? Of course, more speculative theories go even further. They draw on ancient maps, such as the famed Piri Reis map, which some claim shows parts of Antarctica's coast free of ice. They cite legends of lost civilizations in the southern hemisphere. Some propose that these tunnels could be part of a now-buried city or outpost, one lost to time, swallowed by the advancing ice long before recorded history. But there is no proof. Only shadows beneath the ice, shadows that don't align neatly with natural models and yet defy definitive interpretation. As always in Antarctica, what remains hidden may be more powerful than what is revealed. Why has this region remained so understudied? Why do the formations under Queen Maud Land appear so structured in certain places, more structured than similar features elsewhere on the continent? And what might we find, if we ever gain the technology or the will to go deeper? For now, the tunnels lie undisturbed, wrapped in glacial silence and scientific caution. Instruments record their outlines, Satellites measure their dimensions, but no one has entered them. No probe has descended into their twisting depths. No camera has captured their walls. They remain part of Antarctica's silent enigma, a hidden web beneath the ice, connecting mysteries we have yet to fully understand, and perhaps, just perhaps, waiting patiently to be discovered. As we move beyond the shadowed labyrinths beneath Queen Maud Land, the ice itself begins to speak, quietly, but with a story far older than any tunnel or cave. For while some mysteries lie hidden in structure and form, others are encoded in the very fabric of the ice, in its ancient compacted layers pressed silently over eons. Stretching across the frozen continent, Antarctica's ice sheet is more than a geological feature. It is a time capsule, each layer representing snowfall from tens of thousands, even hundreds of thousands of years ago. As ice accumulates, year after year, it compresses, locking away microscopic bubbles of air, particles of dust, and traces of life. Ice cores, extracted like long frozen scrolls, have become one of the most valuable tools in the study of Earth's deep past. But not all findings from these cores are easily explained. In several regions, particularly near Dome Fuji, Vostok, and Bird Station, scientists have encountered something unexpected: carbon-rich layers, hidden deep within the otherwise pristine strata of the Antarctic ice sheet. These layers, dark, silty, and chemically distinct, appear suddenly, interrupting the otherwise uniform bands of compressed snow and frozen atmosphere. At first glance, they might resemble deposits of volcanic ash, thin, soot-like smears left behind by eruptions from distant volcanoes. Indeed, some of them are. The atmosphere carries ash across continents, and ancient eruptions can leave thin black signatures in the ice. But others don't match the chemical profiles of known volcanic events. Their distribution, composition, and age present a more complex picture. Some of these carbon-rich bands contain unusually high concentrations of amorphous carbon, graphitic particles, and even organic compounds, substances not typically associated with airfall or localized fires. Their carbon isotope ratios suggest terrestrial, possibly even biological, origins. How then did these layers form? And more puzzlingly, why are they found in ice estimated to be over 200,000 years old? One widely accepted theory proposes that these carbon-rich layers could be the result of massive wildfires, epic continent-spanning blazes that once raged across now vanished forests, sending clouds of soot and organic particulates into the sky, which then drifted across the southern hemisphere and settled over Antarctica. This would explain the presence of plant-derived carbon and occasional spikes in greenhouse gas concentrations found within adjacent layers. But even this idea opens doors to deeper mystery. For Antarctica, as we know it today, is a polar desert. Harsh, lifeless, and locked in cold for at least 15 million years. The idea of a wildfire-derived carbon layer requires a world very different from the one we inhabit, a world where vegetation thrived in places long since buried under ice. Could this be evidence of ancient, forested Antarctica? Paleobotanical research gives this theory weight. Fossilized wood, pollen, and even root systems have been found in places like the Transantarctic mountains, suggesting that during periods of Earth's distant past, particularly the Eocene around 40 million years ago, the continent supported a lush, temperate ecosystem. But here's the catch. Many of these carbon-rich layers appear to be far younger than that. Some have been dated to around 20,000 to 80,000 years ago, long after Antarctica was presumed to be fully glaciated and devoid of life. So how does one reconcile the presence of organic carbon from unknown sources in a land supposedly lifeless for millennia? This is where speculation begins to creep in. Some researchers suggest that the ice sheet itself may conceal pockets of ancient biomass, perhaps even entire ecosystems, trapped under pressure and slowly decaying, releasing compounds that migrate upward into the ice. Others propose more radical ideas. Could these be traces of extraterrestrial carbon, delivered by meteorites or cosmic dust clouds during poorly understood epochs of Earth's climate history? And then, there are the theories that edge into the unorthodox. A few independent investigators, often working outside traditional academia, have speculated that these carbon bands may represent the remnants of an ancient civilization, one lost to time and ice. They point to the chemical complexity of certain layers, their association with trace metals and isotopes rarely found in natural settings. Could these be industrial residues? Could they be the soot of ancient fire, not from trees, but from machines? Mainstream science offers no support for such ideas. The presence of carbon, even in complex forms, does not prove civilization. Nature is infinitely capable of producing complexity, especially over vast timescales. But the gaps in understanding remain. No single theory yet accounts for all the anomalies, the timing, the composition, the context. Carbon-rich layers are known, but not fully explained. Some cores contain multiple layers, spaced at irregular intervals, suggesting repeating events, or cycles. Others appear solitary, as if marking a unique, singular disruption in the climate system or the biological history of the planet. What then triggered them? Was it a change in ocean currents, stirring up buried organic matter? A massive volcanic event unlike any we have yet identified? Or something else entirely, something we have not yet dared to name? The story of these layers is far from finished. As drilling projects reach ever deeper and analytical technologies improve, we may soon unlock more of their secrets. But for now, they remain cryptic messages in the ice, inked in soot and carbon, signed by an unknown hand. What would we discover if we followed these bands to their source? What story would they tell if we could hear it clearly, and perhaps most haunting of all, what else lies buried, waiting, just below the surface? From the soot-laced ribbons of carbon buried deep within the Antarctic ice sheet, we turn to another subtle signal, also frozen in time. Not one of color or texture, but of invisible forces, etched not by chemistry, but by magnetism. Beneath the piercing blue-white surface of East Antarctica, at remote outposts like Dome C and Vostok Station, scientists have extracted ice cores plunging over 2 miles into the ancient past. These cores are more than mere frozen water. They are memory, layered and pressed into the language of millennia. As these icy columns are slowly unfurled in laboratories around the world, researchers track more than just gases and particles. They look for the whisper of something far more elusive, the fingerprint of Earth's magnetic field, locked within microscopic traces of iron-bearing minerals and volcanic ash. This is the study of paleomagnetism, a window into the behavior of our planet's magnetic shield over geological time. Under normal circumstances, the Earth's magnetic field is a fairly stable phenomenon, generated deep within the liquid outer core as molten iron flows and rotates. But it doesn't stay constant. Periodically, it weakens, drifts, or even flips entirely, reversing the positions of magnetic north and south. These reversals, though rare, have occurred many times throughout Earth's history. But something strange begins to emerge when we study the Antarctic ice cores in detail. In multiple samples, particularly those dated between 780,000 and 12,000 years ago, researchers have documented anomalous magnetic signals, subtle deviations in the orientation and strength of magnetic particles embedded in the ice. At first, these anomalies were thought to be mere noise, errors in instrumentation or local disturbances caused by volcanic ash layers. But as more cores were studied, a pattern began to form. Certain periods in the past show unusual alignments, deviations not consistent with the expected path of geomagnetic field migration. In some cases, the magnetization within these layers appears locally reversed, as if some unknown force had altered the magnetic imprint of particles after they settled into the ice. In other layers, the strength of the magnetic signal seems far too weak, suggesting a temporary collapse or severe disruption of Earth's magnetic field itself. What could cause such events? One hypothesis is that these signals mark short-term disturbances known as geomagnetic excursions, brief episodes when the Earth's magnetic field becomes unstable, wandering dramatically without fully reversing. One such event, the Lasham excursion, occurred around 41,000 years ago and is well documented globally. The ice cores from Antarctica seem to register this event, but also hint at other excursions that are not yet fully understood. Curiously, some of these unexplained anomalies align with other irregularities in the ice record: abrupt climate shifts, spikes in cosmic radiation, or the deposition of unusual isotopes like beryllium-10, markers typically associated with a weakened magnetic field allowing more solar and cosmic radiation to reach the surface. Might these phenomena be interconnected? Could Antarctica's paleomagnetic anomalies be the silent record of global disruptions, clues to catastrophes long forgotten? Some scientists have speculated that sudden shifts in the geomagnetic field could be triggered by changes in Earth's core dynamics, events that might also influence volcanic activity or even mass extinctions. Others suggest that high-energy cosmic or solar events, such as supersolar flares or nearby supernovae, could have temporarily scrambled Earth's magnetic shield. And yet, the anomalies in the ice don't always match known events. Some appear isolated, too brief or too localized to align with global reversals or cosmic triggers. They are strange, narrow, and faint. But they are there. This has led a handful of researchers to explore more speculative ideas. Could the ice itself have preserved magnetic signals from external sources, objects in near-Earth orbit, for example, or interactions with geomagnetic anomalies below the crust? Might there be something beneath the ice, deep under Antarctica's bedrock, influencing the alignment of particles at the surface? Queen Maud Land, for example, is known for one of the largest gravitational anomalies on Earth, centered around the Wilkes land mass concentration. Some have proposed that such subsurface features, perhaps remnants of ancient asteroid impacts, or even hidden geological structures, could exert local magnetic influence, subtle enough to escape modern detection, but strong enough to twist the alignment of airborne particles as they settled onto the Antarctic snowpack. And then, as with many Antarctic mysteries, there are the fringe theories, spoken quietly, often at the edge of credibility yet persistent. Some have asked whether these magnetic anomalies might be evidence of long-lost technologies, devices or materials with magnetic properties that have somehow influenced the surrounding ice. Proponents of these ideas point to localized and repeating anomalies as possibly artificial in origin, perhaps relics buried beneath the ice from an era before written history. No hard evidence supports such claims, and yet the questions linger in the air, unanswered. Skeptics, of course, remain cautious. Ice is a complex and delicate recorder. Factors like wind, temperature, moisture, and chemical interaction can all affect the magnetic particles within it. But even with these challenges, the paleomagnetic record continues to intrigue. What do these faint, distorted traces tell us? Are they mere atmospheric echoes of a turbulent magnetic past, or the signs of deeper, hidden processes at work beneath the ice? As research continues, new techniques, such as ultra-high-resolution magnetometry and cryogenic scanning, are being developed to decode these magnetic messages with greater clarity. Yet for now, the story remains frustratingly incomplete. The ice cores whisper their secrets in alignment and inversion, in strength and silence. signals shaped by forces that stretch beyond the human timescale, beyond the boundaries of current understanding. And so we are left with the lingering question: what is Antarctica still trying to tell us in the quiet curves of its magnetic memory? As the paleomagnetic signatures fade beneath the weight of ancient ice, they leave behind more than just questions of geomagnetic wanderings. They open a door to deeper layers, darker waters, and signals that seem to pulse from beneath the surface. Our journey now turns to a place few have ever seen, and fewer still understand: Lake Mercer. Hidden beneath over 1.2 kilometers of solid Antarctic ice lies a subglacial body of water that has never been touched by sunlight. Lake Mercer, a vast liquid reservoir buried beneath the Wilkes ice stream, remained unknown to the world until satellite altimetry and ice-penetrating radar first hinted at its existence in the early 2000s. What lies beneath this colossal lid of ice? Could it be merely a pool of melted water, sequestered by geothermal heat and insulated by pressure? Or does Lake Mercer hold something far stranger, something that has eluded detection for millennia? In 2018, a team of U.S. researchers under the SALSA project, Subglacial Antarctic Lakes Scientific Access, launched a mission to bore down to this hidden lake. Using a specialized hot water drill, they melted their way through the dense glacial sheet, eventually reaching the lake in early 2019. It was only the second time in human history that a subglacial lake in Antarctica had been directly sampled. What they expected to find was microbial life, ancient extremophiles perhaps, organisms that had survived in isolation for tens of thousands of years. What they didn't expect was the signal. Even before the borehole was completed, unusual readings began to filter back from the instruments lowered into the ice. Low-frequency electromagnetic pulses, weak, rhythmic, and remarkably consistent, were picked up by equipment designed to monitor subglacial conductivity. At first, the team suspected interference from nearby drilling machinery or atmospheric noise. But the signals persisted, even when all equipment was powered down. They emanated from below. Described as a cryptic oscillation, the signal didn't match the expected background patterns generated by geothermal movement, water flow, or natural ice flexure. It was something else, something unexplained. Was it simply a previously undocumented interaction between glacial ice and subglacial water? An echo of shifting masses, perhaps amplified by the geometry of the lake basin? Or could it be a resonance? A kind of harmonic feedback loop born from the interaction between ice, pressure, and mineral composition deep within the Earth's crust. For months, the data was studied, parsed, and debated. The signal was real. That much was clear. But what caused it remains elusive. Interestingly, some researchers noted that similar low-frequency electromagnetic anomalies had been recorded near Lake Vostok, Antarctica's largest known subglacial lake. There, too, scientific instruments had picked up unexplained pulses, leading some to speculate about unknown natural processes, or, in more imaginative circles, the possibility of artificial origins. Lake Mercer, though much smaller than Vostok, became the focal point of fresh theories. Some hypothesized that brine pockets, highly saline reservoirs trapped under the ice, could generate electromagnetic pulses through electrochemical interactions. But the consistency and rhythm of the signal complicated this theory. Brine activity is chaotic, subject to thermal flux and pressure gradients. But this signal seemed almost deliberate. Others pointed to mineral compositions deep in the bedrock beneath Lake Mercer. Could magnetite or other conductive materials be playing a role, responding subtly to Earth's magnetic field in ways we don't yet fully understand? Still, there are those on the fringes of the scientific community who have posed more controversial ideas. What if the signal is the byproduct of movement, mechanical or engineered? Could an ancient geothermal energy source exist beneath the ice? A system of caverns or tunnels, once active, now silent but still humming with residual energy? It's a leap, certainly, but not one without precedent in Antarctica's long history of unexplained anomalies. And then there's the biological hypothesis, perhaps the most provocative of all. Some have proposed that the signal is biological in origin, not from machinery, but from life. Not microbial, but something larger, something capable of producing regular movement, vibration, or electromagnetic disturbance through natural behavior. The very idea sounds improbable, but in 2020, scientists discovered unexpected movement in the sediment layers of Lake Willans, indications of vertical displacement and pressure cycles that could not be fully explained by water flow or ice sheet flexure alone. Could Lake Mercer harbor more than microorganisms? Could isolated evolution, cut off from the surface world for hundreds of thousands of years, have created life unlike anything we know? So far, samples brought up from Lake Mercer show signs of microbial life, mostly extremophilic bacteria, as expected. But that is all we've seen. Less than 15% of the lake has been sampled. The rest remains untouched. And the signal? It still has not been explained. It was logged, documented, and analyzed, but no definitive answer has been published. After the initial field season ended, funding complications and logistical challenges halted deeper exploration. For now, Lake Mercer has gone quiet again, its surface refrozen, its secrets sealed once more beneath a kilometer of Antarctic ice. Does the signal continue in the dark, unheard by human ears? Is it geological, chemical, biological, or something else entirely? The Antarctic ice is patient. It has waited for millions of years, quietly preserving its stories in cold silence. We have only just begun to listen, and as we turn away from Lake Mercer, one is left with the unmistakable sense that something is still there, just out of reach, just beyond explanation. What else lies below that ancient ice, humming quietly beneath the silence? As the echoes from Lake Mercer fade into the frozen dark, another kind of signal rises, not electromagnetic, not auditory, but gravitational. Silent and invisible, yet undeniably present. A signature etched, not in sound waves, but in the very fabric of the Earth. It is found not through sensors lowered into boreholes, but through satellites scanning the globe, mapping the gentle undulations of gravity as it shifts, ever so slightly, across our planet's surface. And in these gravity maps, composed with astonishing precision by missions like NASA's GRACE satellites and the European Space Agency's GO-SEE project, Antarctica reveals a secret it cannot bury, a massive, unexplained anomaly beneath the ice. The location is Wilkes Land, in East Antarctica. At first glance, there is nothing unusual about the region. A vast, remote expanse of whiteness, cloaked in unbroken ice. Few humans have ever stood upon it. Fewer still have had reason to suspect anything unusual beneath its surface. But when researchers began analyzing gravitational data across the continent in the mid-2000s, a strange feature emerged: an enormous mass concentration, or mascon, beneath Wilkes Land. The anomaly spans over 300 kilometers in diameter and is buried beneath more than a mile of ice. Its gravitational pull is distinct, localized, and oddly persistent. Simply put, something incredibly dense is sitting beneath the ice, and no one knows exactly what it is. One early theory suggests it may be the remnants of a giant asteroid impact. The shape of the gravitational depression loosely resembles an impact basin, and some have even speculated that it could rival the size of the Chicxulub crater, the impact site linked to the extinction of the dinosaurs. If such an event had occurred here, it might date back to the late Permian or early Triassic period, long before any written human history. But unlike Chicxulub, No definitive impact structure has been conclusively mapped beneath the ice. The data remains inconclusive, and yet the mass is real. Instruments confirm it. Satellite after satellite records its presence. This strange, dense concentration deep in Earth's crust, its signal quietly bending gravity's otherwise subtle rhythm. What then could it be? Geophysicists have posited that it might be a large magmatic intrusion, a dense accumulation of volcanic rock formed millions of years ago when Antarctica's tectonic plates were more active. But again, the anomaly's sheer scale raises questions. Few other intrusions on Earth are so massive or so isolated. More speculative minds have gone further. Some fringe theorists suggest the mass could be artificial, or at least non-natural in origin. A long-buried structure? An ancient city sealed beneath ice over eons of snow and silence? This theory gained momentum in internet circles after the release of certain declassified satellite images, showing unusually angular features in the surrounding ice formations, though mainstream scientists have attributed these to natural glacial patterns and crevassing. Still, the location of the anomaly is striking. It lies near the edge of what some early 20th century explorers and wartime powers regarded with keen interest. Wilkes Land is also relatively close to the area claimed by the former German Antarctic expedition of 1938–39, which staked out a portion of the continent now called Queen Maud Land. Could there be a connection? Is it merely coincidence that gravity maps highlight the same region long wrapped in geopolitical intrigue and secrecy? Even more curiously, the anomaly sits beneath one of the most inaccessible zones in all of Antarctica. Research in this area is limited, not only due to its harsh conditions and isolation, but because, according to some reports, aerial routes over parts of this region are restricted or avoided. Officially, these are due to safety concerns or magnetic interference, but to others, the pattern suggests that something beneath the ice is being carefully monitored or concealed. The data that does exist only deepens the mystery. Core samples taken nearby indicate unusual thermal readings. Subsurface heat inconsistent with known geothermal gradients. Some have interpreted this as a sign of residual energy from the ancient impact. Others have ventured darker possibilities, an active source of heat of unknown origin deep below. How does one explore a place so buried, so distant, so untouched? Despite advances in radar and satellite imaging, ground-penetrating signals have limited success in fully resolving structures beneath this much ice. And without physical excavation, nearly impossible in such extreme depths and climate, many of the theories must remain just that, theories. Still, the anomaly sits there, silent and unmoving, like a stone buried in memory. We cannot see it, but it tugs on the world around it. Satellites detect its subtle gravitational influence as they drift overhead, pulled ever so slightly off course, like whispers caught on the wind. Could this mass be a relic of a primordial Earth, formed when the crust was young and unstable? Or is it the echo of a forgotten cataclysm, a scar from a cosmic collision long lost to time? Might it be something else entirely? An artifact of ancient civilizations, as some have daringly imagined? Or simply the result of natural forces we have not yet fully grasped? We stand on the edge of knowledge, gazing at the anomaly not with certainty but with awe. As the cold winds sweep across the Antarctic plateau, and as satellites continue their quiet vigil above, one question lingers, soft, persistent, and unanswered. What lies beneath Wilkes Land? What weight rests beneath the ice? Waiting. Beneath the endless white of the Antarctic ice sheet, time lies frozen. Each layer, compacted under the immense pressure of millennia, is a page in the planet's long and quiet history. A story told not in words, but in crystalline bands of snow, ash, and ancient air. But every so often, as researchers drill deeper into the ice, into its thick, dark memory. They encounter a disruption, a moment of sudden warmth, locked in time, a melt pulse. The location is often remote, places like Dome Fuji, Vostok Station, or the Concordia Plateau. In these high, isolated regions, the ice runs more than 3 kilometers deep. The air is bone dry, the wind sharp and unrelenting. It is, by all accounts, one of the most inhospitable environments on Earth. And yet, hidden within this frigid desolation are pockets of strange warmth. Thin, darkened bands appear in otherwise uniform cores, layers where the structure of the ice has changed. Crystalline borders softened, trapped bubbles disturbed. As if something, at some time, melted through a layer, then froze again just as quickly. The phenomenon is called a melt pulse, and while the term may sound benign, its implications are anything but. Ice core records are, in many ways, the Earth's most reliable memory banks. They preserve chemical signatures of volcanic eruptions, atmospheric shifts, even distant meteorite impacts. So when a melt pulse appears, seemingly out of nowhere, it prompts serious questions. What could have caused a spike in temperature in a region that rarely climbs above -50 degrees Celsius? Some of these pulses correspond with known warming events in Earth's past, brief interglacial periods, or volcanic winters followed by rebounds. But others appear isolated, anomalous. They don't match global trends. They are brief, intense, and deeply localized. Take, for example, the anomalous melt layers discovered in East Antarctic cores dated roughly 15,000 years ago. According to most climate reconstructions, this period should have been in the grip of a cooling trend. Yet in multiple locations across the continent, researchers found signs of abrupt melt events, water that had briefly percolated downward before refreezing in delicate, chaotic sheets. Some scientists attribute these to basal heating, geothermal warmth from deep within the Earth itself. It's true that Antarctica sits atop a fractured crust, and in some regions, the mantle's heat does creep upward, imperceptibly warming the base of the ice sheet. But this doesn't explain the vertical positioning of many melt pulses. Some are found far from the bedrock, halfway up through layers that should have remained untouched by geothermal influence. Could sudden bursts of atmospheric warmth have reached these heights? Here, too, we find contradictions. Satellite data and climate proxies suggest no corresponding warming in the surrounding environment at the time these melt events occurred. No solar maximum, no recorded volcanic activity to introduce greenhouse gases, and no large-scale climate shifts to account for such localized, abrupt changes. So what then? Some propose meteoric activity, a comet fragment or bolide impact nearby, its energy briefly radiating through the ice. While possible, the lack of associated debris layers casts doubt on this theory. Others have speculated about subglacial volcanic eruptions, rare but not unheard of. A sudden geothermal flare could, in theory, warm the ice vertically through convection. Yet the thermal pattern left behind in many melt pulses doesn't match that of known subglacial volcanic activity. There are no telltale ash layers, no disrupted gas isotopes, just heat, momentary, intense, and gone. Then there are theories that move beyond the scientific mainstream. One idea, though unproven, suggests that certain melt pulses could be related to artificial activity, perhaps from earlier periods of human or non-human technological experimentation. Subterranean heat sources, now long dormant, leaving behind only the ghost of their presence in the form of a heat scar, preserved in frozen time. Another fringe theory, highly speculative but nonetheless compelling, points to the possibility of deep Earth energy releases, such as sudden magnetic anomalies or tectonic discharges that interact with crystalline ice in unpredictable ways. A sort of planet-borne event, happening not above, but within. What adds to the mystery is the recurrence. Melt pulses don't appear just once or twice. They surface in multiple locations, across different timescales. Some are separated by tens of thousands of years. Others occur in clusters, always small, always fleeting, but always unexplained. Are these signals of a pattern we do not yet understand? A climate rhythm buried too deep in time for us to hear? And what does it mean for our understanding of the past and the future? Because while Antarctica is often thought of as static and frozen, these melt pulses are reminders that it is alive, dynamic, reacting not just to the world above, but perhaps to forces beneath or beyond. Could these events be early indicators of changes still to come? Clues that the continent is not as dormant as it appears? Or are they echoes of phenomena from a time so ancient we've forgotten how to read them? The ice remembers, but it does not explain. As the drilling rigs hum quietly atop the snow, lowering their hollow drills meter by meter, we await answers. But what we find, more often than not, are questions. Faint scars of forgotten heat, moments when the cold gave way. And then, silence. What, we must ask ourselves, stirred the ice, only to disappear again? And more curiously, will it return? As the endless white stretches across the Antarctic landscape, a peculiar mystery lingers in the very atmosphere above the frozen continent. In a place known for its starkness, a place where few dare to venture, something rare and unexplained has been witnessed. A strange green glow emanating from beneath the ice. This light is not an aurora, nor the reflection of the sun off the icy peaks. It is something different. A faint, unearthly green hue that appears with no clear origin, no obvious explanation. It appears under the cover of night, or when the sun's rays are absent, and lingers for mere moments, as if to tease the observer with its presence. The phenomenon, reported by researchers at various Antarctic stations, first caught widespread attention in the early 2000s. At first, it was dismissed as an anomaly of the extreme weather or the product of natural processes. Yet, as sightings continued and increased in frequency, the mystery only deepened. The green glow is often seen near certain ice formations or above specific regions, like the vast expanse of the Antarctic Plateau, or near subglacial lakes such as Lake Vostok. Sometimes it emerges from cracks in the ice, other times it lingers at the edges of vast glaciers, a faint pulse of color against the icy expanse. It is not the kind of glow that could be easily explained by natural sources such as meteors or reflected light. This glow comes from within the continent itself, like some forgotten fire beneath the ice, faint yet present, lingering just long enough to spark curiosity before fading again into the shadows. At first, many assumed the glow was a form of bioluminescence, perhaps from microorganisms within the ice. Antarctica, after all, is not as barren as it may seem at first glance. In the depths of its ice and in the waters hidden beneath its glaciers, microbial life has been found, existing in the most extreme environments. Could these organisms, unknown and unseen by most of humanity, be responsible for this faint glow? The problem with this theory, however, lies in the environmental conditions of Antarctica. Bioluminescent organisms are usually found in warmer, wetter environments, oceans, forests, or deep caves. The freezing temperatures and lack of sunlight in the Antarctic would make it unlikely for such organisms to thrive, let alone produce enough light to be visible to the human eye. As researchers probed deeper into this mystery, another potential explanation was raised. The glow could be related to a rare form of ionization. Some scientists believe that electromagnetic energy, interacting with the atmospheric conditions and the ice sheet's physical properties, could cause ionized particles to produce light. In this scenario, charged particles in the atmosphere, possibly from cosmic rays or solar wind, could be interacting with the ice in such a way that it generates the unusual green glow. But this theory also presents its own questions. Ionization effects, especially those powerful enough to produce visible light, are usually tied to much more intense conditions than those present in Antarctica's isolated, high-altitude atmosphere. And yet the glow persists in a way that doesn't align with what we know about ionized light phenomena. Its color is also curious. Green is not a typical hue seen in ionization events, which usually produce blue or white light. Why green? Could it be something far more extraordinary? Some have raised more speculative theories. Could this green glow be tied to the mysterious subglacial lakes, like Lake Vostok, buried beneath miles of ice? These lakes, isolated for millions of years, have been described as time capsules, preserving ancient environments from long before humanity's existence. What if the green glow was some form of signal, an energy or electromagnetic phenomenon triggered by the changing conditions in these ancient lakes? Perhaps it is a remnant of an unknown process, one that could hold clues to the Earth's distant past, or even hint at life forms, unlike anything known to science, living beneath the ice. Then there are those who suggest a much more unconventional explanation, one that links the green glow to something more enigmatic. Could the glow be a sign of extraterrestrial activity? After all, Antarctica has long been a subject of fascination for those who believe in ancient astronauts, unexplained artifacts, or alien technologies buried beneath the ice. Some claim that the strange occurrences, including unexplained electromagnetic anomalies and the glow itself, are signs of alien presence, perhaps even of hidden structures or technology buried deep within the continent. These ideas remain fringe theories, but they add to the air of intrigue surrounding this mysterious light. Yet, despite all the theories, the green glow remains largely unexplained. Researchers continue to study the glow, employing advanced equipment to measure electromagnetic fields, cosmic radiation, and the behavior of the ice. But so far, no conclusive answers have emerged. The glow continues to appear sporadically, always just out of reach, as if the ice itself is hiding its secrets from prying eyes. Some scientists remain cautious, suggesting that the glow may ultimately be a combination of natural, physical processes interacting in ways we still don't fully understand. Others continue to speculate on the more extraordinary possibilities, the what-ifs that keep them coming back to the continent year after year. What makes the mystery of the green glow so tantalizing is not only its unexplained nature, but also the sense that it might be the beginning of a deeper, more profound mystery, one that connects Antarctica to an ancient, forgotten past, or perhaps even to something beyond our planet. As the green light flickers and fades in the darkness, we are left with more questions than answers. What does it mean? Is it simply a natural phenomenon that we haven't yet unraveled? Or is there something more profound hidden beneath the ice? One thing is certain. The green glow is not just a fleeting anomaly, but a reminder that beneath the surface of this frozen land, there are secrets waiting to be discovered, just beyond the reach of our understanding. As the last traces of the strange green luminescence faded across the Antarctic sky, the attention of researchers turned once again to what lies beneath the ice. Specifically, to the odd patterns that seem to defy natural formation. Deep beneath this ancient continent, radar instruments have returned signals that suggest something unexpected: shadows. But not random, chaotic shapes as one might expect from the rugged, frozen terrain. These shadows are geometric, angular, repeating, polygonal. It was during routine ice-penetrating radar surveys, part of broader geological mapping missions across East Antarctica, that researchers began noticing something peculiar. In regions near the Pensacola Mountains, west of Queen Maud Land, and along the edges of Dome Fuji, radar data revealed recurring shadows, interruptions in the reflected signal, shaped like regular polygons, hexagons, rectangles, even perfect triangles, patterns too organized to be dismissed as mere coincidence. In a place sculpted by wind, pressure, and ancient glaciation, nature rarely carves such symmetry. The Antarctic landscape is marked by the chaotic, the fragmented, the worn. Cracks in the ice form without pattern. Crevasses open with reckless asymmetry. So why, then, do these radar images hint at such order, buried hundreds, sometimes thousands, of meters beneath the surface? Some of these shadows stretch across hundreds of meters, too large to be dismissed as equipment artifacts, too distinct to ignore. At first, the prevailing thought was that these were natural subglacial formations, volcanic intrusions, mineral deposits, or ice shelf fractures layered over millennia. But the angles, the repeating geometry, they whispered of design. Was it possible that these were remnants of ancient geological processes? Could tectonic stress fractures, under precise conditions, produce uniform shapes that mimic architecture? Some geologists have proposed such ideas. Polygonal terrain, they argue, can form in permafrost regions due to the thermal contraction of the ground, producing hexagonal cracking. But these usually appear on the surface, and rarely with the clarity and scale seen in Antarctica's radar returns. Could the answer lie in Antarctica's volcanic history? Beneath the thick glacial cover, the continent hides more than 100 volcanoes, many long dormant, others potentially still active. Could lava tubes or collapsed magma chambers have formed these polygonal voids? Again, perhaps, but the regularity and pattern of some of these formations challenge that narrative. More fringe hypotheses have emerged as well, ones that peer far beyond the boundaries of conventional science. Some researchers, intrigued by the precision of the radar images, have questioned whether these structures could be artificial. Could they be remnants of a lost civilization, once thriving on this land before the continent froze over? The idea, while dramatic, finds faint echoes in speculative theories that Antarctica once sat closer to the equator, a notion occasionally referenced in alternative historical interpretations of ancient maps, like the Peary Race map of 1513, which some claim depicts Antarctica ice-free. Others draw connections to the concept of ancient advanced cultures whose knowledge and structures have long since been buried beneath the ice. If such a civilization did exist, could these polygonal impressions be ruins, collapsed temples, road networks, or city foundations preserved beneath kilometers of snow and time? And then, there are even more unconventional interpretations. Could these formations be the result of extraterrestrial activity? In some fringe circles, the shapes are seen as possible landing platforms or entrances to hidden installations, ideas amplified by the presence of known no-fly zones in certain Antarctic regions and past reports of military interest in unexplained ice anomalies. While such theories often stretch the imagination, they do underline a central truth: we simply do not know. Scientists are cautious, of course. Satellite-based ground-penetrating radar systems, while advanced, are not immune to misinterpretation. Signal noise, data stitching artifacts, or shadow effects from layered ice beds can all produce misleading patterns. And yet, these particular radar shadows have shown up on multiple surveys, conducted by independent teams across separate decades. Why do these patterns continue to appear, often in the same locations, defying conventional geological expectations? The challenges of conducting deeper exploration only deepen the mystery. Drilling in Antarctica is extraordinarily difficult, both technically and logistically. The sheer depth of the ice, often over 2 miles thick, means that reaching these subglacial anomalies directly would require years of preparation, significant resources, and international cooperation. And even then, what would we find? Ice-covered rock, nothing at all, or something else? Despite repeated calls for follow-up investigations, many of these locations remain untouched. Budget constraints, environmental restrictions, and the harsh Antarctic conditions make further study a monumental undertaking. As a result, we are left with nothing more than ghostly outlines, digital echoes of shapes that may hold answers or may simply deepen our sense of wonder. In the end, the question remains: what lies beneath Antarctica's ancient ice? Are these polygonal shadows the fingerprints of natural processes, an elaborate frozen puzzle crafted by the planet's geological hand? Or are they traces of something else, something lost to time and snow? Perhaps in these silent depths, Antarctica is hiding not just secrets of Earth's past, but clues to a story we have yet to understand. As radar traces etched faint geometric shadows beneath the Antarctic ice, researchers turned their gaze toward a very different kind of record, one not carved by instruments, but embedded in stone. A journey from the icy expanse of East Antarctica brings us northeast to a smaller wind-swept island just off the Antarctic peninsula, Seymour Island. Barren and isolated, Seymour Island is a place of contrasts. Here, frigid winds from the Weddell Sea scrape across beige-colored hills, where exposed sedimentary rock lies bare beneath the sky. There are no ice sheets covering this land, just a dry, fossil-rich terrain surrounded by towering glaciers and ocean. To the untrained eye, it seems lifeless, frozen in time. But in truth, it holds one of the richest fossil records on the continent. Paleontologists have long known that Seymour Island is unusual. It is, in essence, a time capsule. Within its layers of sediment lie the remains of ancient ecosystems, creatures that once swam in warm seas or walked the edges of a temperate coast. Fossils here are not rare or isolated, they are abundant. And some, strangely, appear in dense concentrations. Fish, marine reptiles, ammonites, early birds, even fragments of flowering plants. As if, at certain moments in deep time, life gathered here in a way that still puzzles researchers. How is it that such a frigid, remote place now holds remnants of tropical or subtropical life? The answer, at least in part, lies in Earth's changing history. Some 56 million years ago, during the Paleocene-Eocene thermal maximum, Antarctica was a different world. It was warmer, wetter, and largely ice-free. Lush forests stretched across its landscape, and a variety of life forms thrived on its coasts. Yet the fossil concentrations on Seymour Island suggest something more than a simple record of life. They suggest moments of sudden change, rapid deposition, mass mortality. Why do so many well-preserved fossils appear clustered together, almost piled in layers as if swept into place by a single force? Could these be the result of ancient storm surges or tsunamis, washing marine life ashore and burying it quickly in sediment? That is one scientific explanation, plausible, supported by sedimentology and stratigraphy. Another possibility is the sudden drop in ocean oxygen levels, suffocating marine life en masse and leading to localized die-offs. But not all evidence points clearly in one direction. Some fossil beds show remarkable preservation, intact skeletons, delicate bone structures, even impressions of soft tissues in some cases. Conditions would have had to be just right: rapid burial, low oxygen, and minimal disturbance. How often do such perfect conditions occur naturally, repeatedly, in one small area? Moreover, researchers have discovered fossils of land-dwelling creatures in proximity to marine species, sometimes within the same layers. Birds with features akin to modern ducks or falcons, found alongside marine reptiles and fish. What kind of event, or sequence of events, could bring together such disparate creatures in death, preserving them in unison? Some suggest that volcanic eruptions may have played a role, sending ash clouds or pyroclastic flows into the ocean and causing ecological collapse. Others entertain the possibility of ancient meteorite impacts, rare but cataclysmic events capable of triggering localized extinction. Still others point to periodic climatic shifts that may have rapidly altered sea levels, stranding and burying marine life by the thousands. But then come the anomalies, the pieces that don't quite fit. In recent years, the discovery of plant fossils, flowering varieties typically found in much warmer climates, has raised new questions. Could Antarctica have been even more hospitable in the past than previously thought? If so, what caused such abrupt ecological transitions? Why does the fossil record here seem to speak not of a slow evolutionary unfolding, but of dramatic interruptions? More fringe theories reach back further still, suggesting that Antarctica may once have been part of a lost continent, perhaps even the mythical Atlantis. These theories, while unsupported by mainstream archaeology or geology, continue to captivate imaginations. Some proponents point to the strange distribution of fossils on Seymour Island as evidence of a catastrophic event that wiped out a once thriving civilization or unique biosphere. Others suggest ancient pole shifts or crustal displacement events that rapidly moved Antarctica to its current polar position, preserving its fossil record in a kind of geological deep freeze. Could the abundance of fossils on Seymour Island be a simple matter of preservation bias, an area where unique geological conditions just happened to protect and display the remains of ancient life more clearly than elsewhere? Or is it possible that this place marks the site of something more complex, perhaps even a series of events we have yet to fully understand? Despite decades of study, the questions remain. The layers of Seymour Island still yield new discoveries each season, and with each find, the boundaries of what we thought we knew are pushed just a little further. What ancient forces sculpted this fossil-rich land? Why do so many species, from sea creatures to forest plants, appear here together, entombed in time? And what else might lie buried beneath the surface, waiting to speak to us from a forgotten age? As researchers continue their slow excavation of stone and mystery, one thing is certain. Seymour Island is not just a place. It is a question. A whisper from the ancient earth. And its voice, still faint beneath the wind, invites us to listen more closely. As the fossilized whispers of ancient life fade into the background of Seymour Island's windswept ridges, the lens of mystery now shifts from stone to paper, from prehistoric time to the not-so-distant past, and to a place not marked by nature's remnants, but by human footprints that have since vanished into snow. Rising out of the desolation of the Antarctic interior once stood a modest modular outpost known to a select few as Ice Station W. Located in a remote sector of western Antarctica, far from the common tourist gateways and shielded from satellite visibility for much of the year, Ice Station W was never a part of major international headlines. It wasn't the subject of press releases or celebrated research milestones. Unlike McMurdo or Amundsen Scott, its operations were discreet, often logged under broader joint research efforts between military and scientific branches of several Western nations. From the outside, it looked like many other Antarctic field installations, a series of boxy, low-lying structures secured against katabatic winds, half buried under drifts of ice and snow. The kind of place that operates in isolation, powered by its own generators, cut off from the rest of the world for weeks, or even months at a time. But according to those few who have spoken publicly about it, what happened within its walls remains a puzzle wrapped in silence. The records say Ice Station W was primarily established for glaciological and geomagnetic studies in the early 1980s. Positioned near a magnetic anomaly not far from Marie Byrd Land, the station reportedly focused on ice core drilling, atmospheric data logging, and low-frequency seismic monitoring. Nothing unusual, at least on paper. But that's where the trail begins to fray. In the early 2000s, after decades of quiet operation, the station was abruptly decommissioned. No announcement, no closure ceremony, its staff reassigned, equipment packed or abandoned. But most curious of all was what did not leave the ice. The data logs, detailed daily entries that once recorded temperatures, magnetic readings, seismic activity, and communication logs, simply vanished, not redacted, not classified, gone. Archived reports that once included summaries of Ice Station W's seasonal activity now contain gaps. Years are missing. Sections are noted as unavailable or pending review. Requests filed under the Freedom of Information Act in the United States and equivalent transparency laws in other countries have repeatedly returned the same response. No records located. What could have prompted such erasure? Some former support personnel who were once assigned to Antarctic logistics operations have spoken under anonymity about rumors circulating in the early 2000s. Of sudden equipment malfunctions, of inexplicable magnetic disturbances that scrambled compass readings and disabled weather balloons mid-flight, of strange low-frequency sounds, deep resonant vibrations that registered on seismometers but originated from no known tectonic activity. Of course, all of this is circumstantial, whispers, memories reshaped by time. In the world of polar research, instrument errors and environmental anomalies are common, especially in such an unforgiving climate. Yet a handful of researchers claim they saw some of the Ice Station W reports before they were pulled. One described a series of notations logged over the course of 3 weeks. Unstable readings from beneath the ice shelf, magnetic deviation increasing, instruments recalibrated, but anomaly persists. Another referenced unusual patterns in long-wave seismic data, pulses that repeated at precise intervals, too regular to be natural, yet too slow and wide-ranging to match any man-made source. Could these anomalies have been tied to something deeper beneath the ice, perhaps linked to tectonic activity, or relics from an ancient meteorite impact, disturbing the magnetic structure of the region? One mainstream explanation suggests that the station may have simply encountered technical problems caused by fluctuations in the Earth's magnetic field, a well-documented phenomenon at high latitudes. Still, the deeper question remains: why erase the logs? Why not leave them as part of the record, even with disclaimers or cautionary notes? Why strip an entire field station's history from the official narrative? More speculative voices have offered their own interpretations. Some believe Ice Station W stumbled upon something it was never meant to find, perhaps a signal, perhaps a structure, perhaps a glimpse into the ancient geology of Antarctica that raised red flags higher up the chain of command. Others suggest a joint intelligence operation embedded within the scientific mission, and that the disappearance of records reflects not scientific censorship, but national security protocol. A few fringe theorists, often dismissed by academia but undeterred, link the missing logs to broader questions surrounding the secrecy that seems to surround certain parts of Antarctica. Why do certain no-fly zones overlap with regions once monitored by Ice Station W? Is there something still there, beneath the ice, beneath the data, beneath the silence? Officially, no wrongdoing is acknowledged. Ice Station W is considered inactive, and its infrastructure long buried by snow and time. Yet the maps still bear its coordinates, and satellite images occasionally show faint outlines beneath the ice. Was it simply a forgotten footnote in polar research history? A project that outlived its funding or its usefulness? Or is its silence the most telling detail of all? The answers, like the station itself, may now be entombed in ice. And as the wind howls over its lost foundation, we're left with only questions. What was recorded there? And who decided it was too much to share? Was Ice Station W just another experiment lost to the elements, or a door briefly opened to something deeper, darker, and perhaps not yet understood? Whatever the truth may be, it sleeps now beneath white silence and waits. As the last echoes of Ice Station W fade beneath the drifting snow, its data logs swallowed by silence, Antarctica once again reminds us that this continent does not easily give up its secrets. Just beyond the realm of documented history and operational records, a darker and colder mystery begins to take shape, one etched not into parchment or tape, but into the very fabric of the ice itself. High above the eastern sector of Antarctica, satellite instruments, scanning for subtle thermal variations and gravitational flux, once captured a faint, irregular signature beneath a remote expanse of uninhabited ice. What they found would, for a time, go unnoticed. It looked like little more than a distortion, an anomaly in the radar return, blackened and muted, as if something was absorbing signal rather than reflecting it. Later, a closer survey, conducted through ground-penetrating radar, would begin to reveal something else. Beneath the compressed ice sheet, nearly 2 kilometers down, was a massive circular depression, smooth, broad, and seemingly untouched by the usual processes that shape craters over time. Its radius, eerily symmetrical, its perimeter, strangely cold. They called it the Black Ice Crater, not because of its color, though some reports describe the ice layers around it as darker, denser, almost obsidian in hue, but because of the way it swallowed energy. Unlike most subglacial formations, the Black Ice Crater reflected almost nothing back to the instruments scanning it. Sonar, radar, infrared, each returned with data blank spots, dead zones in an otherwise active field of observation. What kind of force could create such a structure? Was it the result of an ancient meteor impact, or something else entirely? The mainstream scientific consensus, as expected, leans toward the familiar. Antarctica, they point out, has seen its share of extraterrestrial impacts. Its ice, in fact, is one of the most efficient natural collectors of meteorites on Earth. Due to the slow movement of the glacial flow and the clean white contrast of the surface, fragments of ancient space rocks accumulate here, often preserved for thousands of years. The idea that a large, deeply buried crater could exist is not far-fetched, but there are inconsistencies. The ice cores extracted near the crater's location tell a peculiar story. Instead of the usual scattering of metallic residue, fused glass, or high-pressure mineral signatures expected from a meteorite strike, scientists found compressed layers of ice unusually rich in certain heavy isotopes, barium, tellurium, and tungsten, elements not uncommon, but in this concentration and pattern, strangely anomalous. Some of these layers appeared as sharply defined strata, almost as if deposited in a single event. And then there is the age. Preliminary radiometric assessments, cross-checked against ice layering and oxygen isotope chronology, date the formation to roughly 12,800 years ago, a time of rapid climatic upheaval, a time that corresponds, intriguingly, with the Younger Dryas period, a sudden and brief return to glacial conditions following Earth's initial warming after the last ice age. Could this be coincidence? Or could the crater be a silent marker of some planetary-scale event? More controversial still are the whispers from fringe researchers, those working outside the standard academic frameworks, who have proposed that the Black Ice Crater may not be an impact site at all. Some argue the shape, depth, and residual field anomalies are inconsistent with natural impact physics. Instead, they describe it as something artificial, perhaps the remnant of a colossal underground structure or energy release, the footprint of something not yet understood. Some even go so far as to connect the Black Ice Crater to ancient myths, stories passed down by civilizations far removed in space and time. From the Sumerian texts of catastrophic skyfire to Native American oral traditions describing a blinding winter that followed a flash from the stars. Could the crater be a geological memory of such an event? A point of contact between Earth and something else? Even among those who reject these more speculative claims, the enigma persists. In 2018, A small scientific expedition attempted to approach the region, seeking to deploy more advanced seismic instruments directly over the site. But the terrain proved hostile. Storms descended without warning. Equipment repeatedly malfunctioned. One of the team's twin-engine aircraft reportedly experienced navigational disturbances, gyroscopes deviating by degrees, only to return to normal once it left the immediate area. Again, such events may have rational explanations. The Antarctic environment is notorious for disorienting instruments, and magnetic interference can occur in regions with high concentrations of subsurface metal. But in a region already shrouded in uncertainty, these minor anomalies feel more like clues than coincidence. So what lies beneath the black ice? A forgotten crater from a past catastrophe? A massive void formed by geothermal collapse? Or something else? A secret, perhaps, that predates even recorded human memory? No excavation has yet pierced the thick ice above it. No mission has reached the center. The deeper scans remain inconclusive. And in the years since its initial discovery, funding for further exploration has quietly dwindled. Perhaps it is safer that way. As the ice groans with the deep, ancient pressure of time, the black ice crater remains untouched, unseen. A silent, darkened scar etched into Earth's most secretive continent. And we are left to wonder, did something fall from the sky? Did something rise from below? Or is this just another of Antarctica's quiet riddles, one whose answer lies too deep to reach? The wind offers no reply, only stillness, only shadow, and only the faint, absorbing silence of the black ice beneath. From the silent depths of the black ice crater, where echoes are swallowed by the ancient ice, we lift our gaze skyward, toward the machines that watch from the edge of space. Satellites, quietly orbiting above Earth, scanning every continent, every ocean, every shifting cloud, without pause or emotion. In theory, their data streams should be unbroken, impartial, and exact. But over one particular region of Antarctica, the flow stutters. The Wilkes Basin. Spanning more than 1,400 miles beneath the East Antarctic ice sheet, the Wilkes Basin is one of the largest known subglacial valleys on the planet. It is immense, twice the size of California, and buried beneath nearly 2 miles of ice. Yet it's not its size that draws curiosity from researchers and observers alike. It is what seems to happen above it. For more than 2 decades, satellites passing over this sector have occasionally encountered unexpected behavior, momentary data losses, signal drops, even brief malfunctions in onboard systems. Engineers reviewing the anomalies typically mark them as transmission noise or software error, routine if not fully understood. But as the glitches persisted, patterns began to emerge. Some satellites, particularly those equipped with radar altimeters or gravity sensors, reported an unusual increase in signal interference precisely when crossing a narrow zone centered above the Wilkes Basin. In a few rare instances, magnetometers aboard polar orbiting craft showed minor but measurable deviations in Earth's local magnetic field. One incident, logged in 2016, involved a European Space Agency satellite that experienced a transient malfunction in its star tracking system while passing over the Wilkes region. Navigation stabilized moments later, but the error caused a cascade of minor disruptions across the satellite's telemetry system, only to vanish once it cleared the zone. The official report cited possible cosmic radiation as a cause, but similar disruptions were not observed elsewhere in the satellite's polar orbit. Is it merely coincidence? Earth's magnetic field is not uniform. It fluctuates, bends, and ripples under the influence of both external and internal forces, from solar winds to deep planetary currents. And Antarctica, with its thick crust and shifting glacial mass, may amplify these irregularities in ways we do not yet fully understand. Mainstream geophysicists have suggested that the anomalies might be linked to the basin's gravitational structure. Indeed, deep radar imaging has revealed a vast mass concentration buried beneath the ice, possibly an ancient, dense rock body or impact remnant. Some believe it could be the scar of a massive asteroid collision dating back 250 million years or more. A wound from deep time now obscured by millennia of snow and silence. If true, could the metallic or magnetic residues from such an impact still exert influence today, subtly interfering with sensitive instruments flying overhead? It's a plausible theory. Yet not everyone agrees. Some researchers have noted that the electromagnetic disturbances recorded over the Wilkes Basin don't fully match what one would expect from simple geological interference. Instead, they appear sporadic, sometimes concentrated at a narrow band of latitude, sometimes dispersed, almost pulsing. Even more curious are the anecdotal reports from military satellites and classified surveillance craft which, according to leaked cables and declassified fragments, have on occasion flagged the area for abnormal sensor reflections. Though details remain obscured by layers of operational secrecy, some speculate that the region may mask or distort infrared and thermal readings in ways that remain poorly understood. Could something within the basin be interfering deliberately? Or is this simply nature's version of static, rare, unpredictable, and difficult to repeat? Theories at the edge of mainstream science suggest everything from geothermal vents to unusual subsurface electrical activity. Others, less cautious, propose the existence of massive caverns beneath the ice, cavities so large they generate their own microclimates or magnetic influences. And then there are the truly fringe interpretations. In a handful of speculative circles, the Wilkes Basin has become synonymous with lost civilizations. Some claim the buried mass is not natural at all, but the remnants of an ancient city or technological structure now frozen under eons of glacial compression. The idea is tantalizing. A hidden complex, shielded from view, emitting trace signals or fields that modern satellites can barely register. But such ideas, however imaginative, remain unsupported by direct evidence. The ice does not yield its secrets easily. Core samples drilled near the region have yet to reach bedrock. Ground expeditions are costly, dangerous, and logistically challenging, and satellite data, while vast, is still open to interpretation. Still, the questions linger. Why does the Wilkes Basin, out of all the vast and empty stretches of Antarctica, produce such oddly consistent glitches in our observation tools? Why do so many of these anomalies cluster around a single ancient mass buried far below the surface? And perhaps most intriguingly, are we witnessing a natural phenomenon still beyond our current understanding? Or is something else, something unexpected, subtly making its presence known? The satellites continue their orbits, the data continues to flow, and yet, over the Wilkes Basin, the signal still bends, just slightly, into silence. For now, we can only observe from above, waiting, watching, wondering what lies beneath.